Hello. Not hearing you. Hello. Yes. Hello. Just
Hello.
Hello. Yeah, you spoke. Ma'am, can we get started?
Waiting for you to give me the
Yes,
green light.
yes. Yeah, I just chatted, sent you a text in WhatsApp. Yeah,
Mhm.
so we'll get started, ma'am.
Sure.
Yeah. George? Yeah. So a very good afternoon to one and all of you over here. So we are starting the first session post lunch. So we have here with us Professor Dr. Rohini. Thank you, ma'am, for accepting our invitation and gracing the occasion. May I request now Dr. Shakti to take over the session to introduce Dr. Rohini. Thank you.
hello, everyone. Welcome to the afternoon session. Um, I'm so grateful for this day where we get to listen to the wonderful talks from achievers from science. So now we have with us Dr. Rohini Godbole, professor at the Center for High Energy Physics, Indian Institute of Science, Bangalore. So Rohini Godbole is an Indian physicist and academician. She's a professor at IIC Bangalore. Rohini Godbole obtained her BSc from Sri Parashuramu College, University of Pune, MSc from Indian Institute of Technology, Mumbai, and PhD in theoretical physics from State University of New York at Stony Brook. She has worked extensively on different aspects of particle phenomenology over the past 3 decades, in particular on exploring different aspects of the standard model of particle physics and the physics beyond it. Her work regarding hadronic structure of high energy photons outlined a variety of ways in which to study it and had implications for the design of next generation electron positron colliders. She is today a part of the International Detector Advisory Group for the International Linear Collider at CERN, which monitors the design and working of the ILC detector. She is also the chairperson of the Panel for Women in Science initiative of the Indian Academy of Sciences. I'm so proud to say that in the year 2019, Professor Rohini Godbole was awarded the fourth highest civilian honor, Padma Shri. Professor Rohini Godbole has been conferred with the Audrey National Du Merit, one of the highest distinctions granted by France to honor eminent professors in 2021. Apart from her work in academics, Professor Rohini Godbole is also a much sought after communicator of science, often delivering talks to young students, scholars, and scientists on everything physics. She is also an avid supporter of women pursuing career in science and technology, and along with Ramaswamy, she edited the book Leelavati's Daughters, a collection of biographical essays on women scientists from India, which was published in the form of a book by Indian Academy of Sciences in 2008. Without further ado, I welcome Professor Rohini to deliver the session. We'd love to hear from you, ma'am. Welcome.
Thank you very much. It's a pleasure to be with you people. I'm sorry that my other commitments do not allow me to participate in the whole day's program, and I will be joining you only for this 1 hour talk. When Dr. Nirmala approached me to talk about it, maybe before that, let me begin my day talk by wishing you all very good greetings on this United Nations Day for Women and Girls in Science, because
Thank you so much.
it should not be only this day that we should celebrate and think about women in science, but in fact it is every day that we need to keep this in mind. And as I said in one of my editorials which I wrote in Current Science, I look forward to the day when we are known as scientists who happen to be women. That is the Indian scientists and engineers. But I think to go to that aim and to go to that goal, path goes actually through a time when we are acutely aware of the gender of the women and gender of the people who participate in science and engineering. It's paradoxical, but that's what it is. So indeed, once again, greetings to all of you. But just to sort of continue what I was saying before, that when Dr. Nirmala asked me to address you people today, I said I want to talk about science and not about women in science. Because finally, the aim of the day is to get more women in science. So it's the science that is important. So I would much rather have a small discourse with you, something about science based on my experiences as a scientist. So let me see. Let me begin by sharing my screen with you. Let me see. Tell me if the screen is visible.
Yeah, ma'am, it's visible.
Okay, so I'm going to share my screen with you. And what I have decided to talk to you about is I have titled it Pursuit of Science and Shifting Goalposts. So let me, without much ado, let me go into to tell you what is the plan of my lectures. So first I will give you some introductory remarks which explains why did I give this title and what do I mean by that title. And then basically what I want to do is I want to discuss these issues about pursuit of science and shifting goalposts with particle physics as an example. So to do that, I have to tell you a little bit about the current status of particle physics, how has the community arrived at this, what are the next steps, and how have the LHC results, that is the results from experiment which we have seen in the newspapers often enough, called Large Hadron Collider, how have the results from the Large Hadron Collider shifted the goalposts? And then in the end, I want to sort of show you that how now the goalposts, shifted goalposts, mean that the research you do at the Large Hadron Collider has a synergy with the explorations of the cosmos and the universe through a variety of probes. So let's see how we go there. See, what is the main point that I want to make in the beginning, in the title? What does the title tell you? What the title means is the following, that progress in science is not always linear. It's not a straight line. And what happens is that standing on the shoulder of giants, like people like Newton, people like Galileo, physics developed as a subject, right? So standing on the shoulders of these giants, the entire community embarks on theoretical and experimental investigations into mysteries of nature. I mean, this is what science is all about. Science is about probing the mysteries of nature, and somewhere we also find out of that we make discoveries which have applications, which improve the quality of human life, which make the human life more pleasurable, longer, healthier, so on and so forth. But the major aim of scientific investigations at the first stage is delving into mysteries of nature. And then what happens usually is that when the community as a whole, the subject has developed, and the community thinks that we have climbed one mountain and reached the peak of the developments in a particular subject, then the vision that we get from this high position of the peak actually raises further questions. That is, our process of seeking answers to questions takes us to a position where we find even more questions. And then we try to answer those questions. And sometimes this privileged position that our investigations give us also rules out the theories which we have thought would be providing answers to our fundamental questions. And from these newly acquired heights of knowledge, we then see that there are still new peaks to be conquered, which had so far been obscured by the mist of ignorance. So this is the basic story of the journey of science. And this is how the journey of science goes on in all subjects. And in particular, what happens to particle physics is what I want to discuss about. So let me tell you, for example, first begin my talk by telling you about recent advances in fundamental physics. So over the last decade, 3 important experiments have presented us with historic discoveries. And you would have read about these historic discoveries by looking at very often even looking at the newspaper reports. So these discoveries are that important. The first discovery is discovery of the Higgs boson at the Large Hadron Collider. And this was really the last step towards establishing the standard model of particle physics. And this got the Nobel Prize in 2013. Then there is a second discovery, which was called high precision cosmology, with experiments that were done with something called Planck satellite. And this actually nailed down the standard model of cosmology. And this got the prize called the Breakthrough Prize, which is equivalent to Nobel Prize, but this is a new prize that has started in the last 5 years. And they got it in 2018. It's the team that got that Nobel Prize. And in 2017, there was a Nobel Prize for the detection of gravitational waves, which was the ultimate verification of Einstein's theory of gravitation. And this was also given to a big team which made the experiment of the detection of gravitational waves possible. So these were 3 experiments which caught the public imagination, and therefore people started asking questions, where do these fields go next? And this topic became a lot of interest. For example, this was a cartoon which I like very much, which explains in some ways, in my opinion, the importance of the discovery of the Higgs boson. So here is this lady, and she is a scientist, and in the background is the Large Hadron Collider sketch, which is the collider which is underground in a tunnel. And she says, we have discovered what nothingness is made up of. And then the other scientist says, yes, it's quite something. So it was a very esoteric, very abstract question that was decorated with the Nobel Prize, because the discovery of the Higgs boson actually convinced us that our understanding of the laws that govern interaction of the fundamental particles actually was the right one. So what is, it completed, so to say, the periodic table of elementary particle physics. And the accepted worldview is that, as we know, everything is made up of molecules. Molecules are made up of atoms. Atoms are made up of electrons and nuclei. Nuclei are made up of neutrons and protons. And these neutrons and protons are made up of the quarks. And not just the quarks that make up neutron and proton plus the electron, but in very high energy conditions, there exist brothers and sisters of these quarks which make protons and neutrons. And therefore, there is a total the number of 6 such types of quarks associated. There are 6 varieties of 3 pairs of the electron and heavier electron, as well as the neutrino, which is associated with the electron. And those are the elementary particles in the universe. everything is made up of these elementary particles. And then there are force carriers, which are, just 1 second. Can you please, I please apologize. There is somebody at the door. I'll come back in a minute. Yeah. So this is really along with these fundamental particles, there must be also the force carriers, which are called the photon, the W and the Z boson, and the gluons. Again, the names are not important, but that is what they are right now. And of course, the omnipresent Higgs boson. So till the Higgs boson was discovered at the Large Hadron Collider, this was not known, and finding it actually finished the total list of the fundamental particles and the fundamental forces among them. And that was actually, in that sense, the periodic table of particle physics was completed. So now what is the story? At the Large Hadron Collider, we have found a Higgs boson whose properties has been checked, and they look exactly like what we expect in the standard model of particle physics, but we have absolutely no indication of any new particles or interactions which the theorists had thought must exist if the Higgs boson has the mass that it is supposed to have found. So what has happened at the Large Hadron Collider has answered a very fundamental question by telling us that the Higgs boson exists, but by showing us that that Higgs boson has a value of the mass, which, if that is the value of the mass, we physicists on theoretical grounds expected something more, some more interactions, some more particles, and we don't seem to have found anything more than these particles and more than these interactions that are contained in this little box. So particle physics actually finds itself in a very, very funny place. And if I were to quote from A Tale of Two Cities, this is a book by Charles Dickens, in case people still read such books. And the first few lines of this book, I reproduce exactly. It is the best of the times, it's the worst of the times. It's the epoch of belief, it's the epoch of incredulity. It is the season of light, it is the season of darkness. It is the spring of hope, it is the winter of despair. So at the same time, it's two things. And a particle physicist exactly feel this way now, because we find that it's the best of the times. We have found the Higgs boson. Standard model is right. It's the worst of the times because we are not finding anything else that we think theoretically must exist if the Higgs boson, since the Higgs boson that has been observed has the mass that it has. So what has happened is that we have found the standard model Higgs, we have proved the standard model, but we have no glimmer of any physics, any interactions, any forces, any particles beyond the standard model that the observed Higgs properties tell us it must have. So what we find now is that we had many, many ideas. The theoretical physicists are very fertile heads. They had many innovative ideas, in fact, and now what we find is that none of those ideas work. Nature is far more subtle than we had thought, and there are new peaks now. These are the new peaks that we need to climb, and that's what makes life of a scientist even more interesting. So we have everything before us because we have these questions which we have to answer. And in some sense, we have nothing before us because in the red I have written this, our innovative ideas have completely failed. So this is the beautiful nature of how some achievements, some wonderful achievements, which help us you to go to a peak, actually bring out for you the new issues, and that's what's happening. So all of us, we can kind of feel a bit like Lord Kelvin, whose name some of you might have heard when you studied thermodynamics, is that there is nothing to be, he said this at 1890 or so. There is nothing new to be discovered in physics now. All that remains is more and more precise measurement. This is what he thought. And I don't know how many of you know it, but the problem that he had said that there are a few clouds, what he had meant was the problem that he said was existent was the black body radiation problem. And the rest is history. Solving that black body radiation problem gave us the entire subject of quantum physics and today's entire world. So we are particle physicists feel something very similar, and they feel that perhaps what remains is more and more precise measurements of the Higgs and the top properties. So the question is that how particle physics is going to move on? In fact, this is a big question that is being discussed the world over. And in fact, even people who are not necessarily particle physicists talk about it. And there is a New York Times op-ed that I reproduce here, where Dr. Sabine Hosenfelder, who is an ex-particle physicist, actually wrote that 10 years in, the Large Hadron Collider has failed to deliver the exciting discoveries that the scientists promised. So where are we going? So my aim today is to tell you how both what the Large Hadron Collider has found and not found has thrown light on the future steps that are to be taken. And before I do that, I also want to tell you how and why this is not just of interest to particle physicists alone. So let me try to tell you that laws of particle physics, about which I'm going on and on and on, these which we have found to be functioning at distant scales of Fermis and smallers, they seem to be of relevance in addressing things that happen on cosmological time scale, that is at the beginning of the universe, and astronomical distance scales, which is millions of megaparsec and above. And the same laws are able to help us formulate answers to the question, how was everything formed? How did the nucleons form? Can we explain the relative abundance of different elements in the universe? Do we know how stars and galaxies formed? And these are the questions which are understood, of course, in terms of astrophysics, electrodynamics, electromagnetism, and what have you. But along with all that, it also needs knowledge of the standard model of particle physics. So this particle physics, which we are studying in these huge collider experiments, and what we learn there is of importance to understand what happened at the beginning of the universe, how did everything got formed, and how is everything moving forward. So this is really the reason why this the discovery like this of the Higgs boson, which I have kind of drawn here, one of the events, that there is one proton beam and another proton collide, produce a Higgs boson, which lives for extremely minute amount of time and then disintegrates into two photons, which are the ones that are detected by the huge detector that has been constructed and in which India has been Indian physicists, not me, but Indian experimental physicists have taken part in building such a detector. So now what has happened? This kind of discoveries brought actually CERN, the colliders, and the high energy physics in limelight. Before these discoveries, high energy physics were actually regularly winning Nobel Prizes. In 18 years, the Nobel Prizes had been given to formulation of the standard model and discoveries establishing the particle content and the interactions of the SM. So out of the number of years that a Nobel Prize is being given from 1905, I think, 18 of those years, the Nobel Prizes were given to people who discovered standard model. So it's an extremely important thing. However, those went unnoticed. It's only this Nobel Prize to the Higgs boson that kind of caught media attention. And that has to do with the fact that the experiment that had to be done to do this was an extremely mammoth experiment, and role of big science, as it is called, has come to the forefront, and it added a sociological dimensions to the answers as to what next. So colliders are the experiments, which machines, which helped us to understand and get to this point in our understanding in particle physics. These are gigantic projects. No one laboratory or not even one country can do it alone. And evaluation of what might be the best energy and what kind of colliders should be best depends on the physics questions which need answers. Long periods are required for these studies. And again, the three communities of particle experimentalists, the theorists, and the accelerator physicists have to work together. Experimentalists have to confirm whether the types of measurements suggested by the theorist are doable. Theorists first go and suggest things that need to be measured and how they should be measured. And accelerator physicists have to tell that the kind of beams as well as the energy and the frequency of the particle collisions that are required by theorists and experimentalists are achievable. So all this takes a lot of study, lot of planning, a lot of input from engineers. So it's the world of experimental and theoretical and accelerator physics is actually a world where theorists, experimentalists, and engineers all work together towards one goal. I just want to give you a small comment on a personal connections. For example, I'll tell you an example of one of the work I myself had done, that many years back, many decades back, we did some work on investigating aspects of the currently known theory of strong interactions. And what we found that it affected predictions for particle production in collision of photons. And in fact, whatever we had done as a purely theoretical exercise actually had implications for the designs of the next generation electron-positron colliders. So, two facts that these colliders had been in discussion since 2000 or so, even before the Large Hadron Collider has started running, which means that these colliders that we are talking about are not even today in existence. They were not even in, but they were already in discussion in 2000 when even the Large Hadron Collider had not started running. And secondly, our work was addressing an issue which had no direct relevance for the collider designs. We just found a new effect in the interaction of photons, which suddenly had implications for the designs of the next generation E plus E minus colliders. So I hope now you see the entire serendipity and the connectivity between different branches of science. Now, colliders actually are a very, very long time scale experiments. For example, the Higgs postulate was made by Higgs, who got the Nobel Prize for it, in 1968. Machine design actually started in 1984, and machine building started in 1998, and experiments were done in 2012. And as you can see, this entire period, if I tell you that I was actually only in 11th class in 1968, and I was present at CERN giving lectures on Higgs physics in 2012, you will realize that this entire time is the lifetime of a young student getting into particle physics and becoming a physicist. So all I'm trying to tell you is that these experiments which have achieved these fantastic achievements actually have a long journey to make before they give you results. So now after this has happened, people started asking questions. Is there life for particle physicists after the Higgs discovery? The answer is yes. Am I just saying it because particle physicists want to keep their jobs? Actually, the answer is no. And to tell you this, I'm going to tell you a few facts. That particle physicists had actually started looking at what after Higgs, decades before the Higgs was found. And this is what was called, I already mentioned it, physics beyond the standard model. And actually, the point is that we had many wonderful ideas about the possible forces and interactions and particles beyond standard model that should exist. And I will try to give you the theoretical reasoning why we had postulated them. But it is just that none of them have been found any proof at the Large Hadron Collider. So we have many, many big ideas which we thought should exist in nature, and they have found to be not true. At the same time, the problem still exists. So how do we solve these problems? That is exactly the story that I want to talk about. So why look beyond the standard model? Okay. So there are many, many rational reasons to look for particles and interactions beyond those in the standard model. One of them is the following. There is something called dark matter in this universe, and that makes up about 27% of the universe. And actually, we don't have any idea. None of those particles that I wrote in that yellow box at the beginning of my lecture can be the dark matter, But the fact that the universe is full of matter that cannot be seen by light, that is actually now proved beyond any doubt. So what is this dark matter? Then we also know that the neutrinos have non-zero masses. This is why the Nobel Prize in 2015 was given. Then also another very surprising fact we find, that the universe contains only matter and no antimatter. That is, matter dominates the universe. So these three are three observational facts which need answers. And particle physics theories right now have no answers to any one of these three questions. We feel the force of gravity, but we do not have a quantum description. We have found a Higgs boson, which has a very small mass, and the universe seems to be expanding at ever increasing rate. All these are puzzles that are still there present in the world of fundamental physics, and we have no answers. So clearly, there exists physics beyond the standard model of particle physics, which might have clues about, which might provide answers to these puzzles. So in this context of the talk, understanding the light Higgs actually is the first challenge. And in fact, much before as I said, much before the Higgs boson discovery happened, people had actually postulated a new theory in which, associated with every particle, there will be another partner, which we call supersymmetric partners. And in fact, with a few of my collaborators, we had actually written this book, How to Look for these Supersymmetric Particles at the Large Hadron Collider. And if if this theory had to solve the problem, namely why the Higgs boson is light, then we needed to find the partners at the Large Hadron Collider, but we have not yet found it. Now, this theory also very naturally predicted a dark matter candidate. So the point is that there are the exact predictions that this theory has made about the new particles that can exist. Large Hadron Collider has looked for them, hasn't yet found them, but in principle, the theory has in it to explain actually all these mysteries correctly. So therefore, interest in studying these theories further still remains. So now let me show you the cosmic connections. I already mentioned dark matter. Let me try to give you more details of what that is. That what happens that somehow in the cosmological experiments, you are able to actually compute the amount of matter in the universe. And right now what we know is that the contents of our periodic table, that is the particles written in that yellow box in the beginning of my talk, account for only 5% of the particles, and there is 28%, 27% is dark matter, which does not interact with light. And then this is something called dark energy, which I'm not going to relate to just now. Now, the fact that 27% forms dark matter, we can draw this conclusion only because we understand the interactions of all the standard model particles, and we know that this 27% of dark matter is going to require physics beyond standard model. What is the evidence for this dark matter? The evidence is the very interesting one, that this is a measurement, it is called rotation curves of galaxies, and this was much more better measurement than original measurement, which was done by a very important astronomer, Dr. Vera Rubin. And what you find is that if there is no dark matter, this is what you would expect, but what you observe is this in some velocity of rotation of galaxies, and you clearly see that clearly the observations tell you that dark matter must exist. So this is again about collisions of galaxies, and this is an example from the bullet clusters, where you see that the part in red indicates the baryonic matter in the two galaxies, and the part in blue indicates the total matter in the galaxy. So clearly one sees that there is dark matter, which and this is measured from different kind of measurements, estimated by different kind of measurements by astronomers. This I already mentioned, that our early universe had in principle equal matter and antimatter, but the universe of today seems to have only matter and antimatter asymmetry. That explanation of this asymmetry in the universe in terms of the known properties of the standard model particles, which are measured in the laboratory, is possible. Now, the observed asymmetry is that n number of baryons over number of photons is 6.1 into 10 to the minus 10, and number of antibaryons to number of photons is almost 0. Now, a quantitative explanation of this difference indicates the need for physics beyond the standard model. And this BSM physics one would like to study at the colliders. So, the last but not the least is the fact that this is the table of all the fundamental particles as we know them today. And what you will find is that there is an electron, there is a muon, there is a tau. These are the heavy electron, two heavy electrons. And these three neutrinos, please note, I call them nu L, nu M, and nu H. So there are three neutrinos. They have non-zero masses. That is proved. And we really don't understand these very, very small masses because you don't need to care about what units these are. All you see is that the mass of the top in these units, top quark, is 173, and the mass of the lightest neutrino in this same units is 10 to the minus 9. You are all science students, so you will realize that these are 12 orders of magnitude in the two masses. So we would like to understand what this is. So now in the coming decades, we'll be probing the universe through different probes. The optical one, that is at Hanley, the radio waves, that is GMRT, the Giant Meter Radio Wave Telescope, which is running near Pune. Then the square kilometer array that India wants to participate and which will be built in Australia and South Africa. Then the LIGO India, the light interferometer gravitational wave detection experiments. Then neutrinos, for which, for example, in India, we are thinking of the Indian Neutrino Observatory, whereas US is thinking of something called DUNE, and as well as IceCube, which are experiments running in the North Pole, and so on and so forth, as well as the colliders, which is the Large Hadron Collider and the International Linear Collider. So now just to tell you what you mean by, say, probing the universe through different probes, here I show you a photograph of the sun from the Earth through photons, which is clear, you really take a picture. And the other one is through neutrinos, and that is here. So now you see that it is the same sun which is being photographed using photons and using neutrinos. How it is done, by what is meant by photographing it through neutrinos, etc., is a long story and another talk for another day. But all I'm trying to show you here is that all these different experiments are probing the same thing. And I'm giving you the example of the sun here. So what are the theoretical challenges? The theoretical challenges for a theoretical physicist like me are understanding the Higgs mass, the value of the Higgs mass. There are technical questions here, and again, I will not have the time or the entire background to be able, have not developed the background to explain this. But there is a theoretical question that is very important to answer, and that is, how do we understand the value of the Higgs mass? How do we understand, or can we understand at all, why in this wonderful table that I showed you, the mass of the ratio of the mass of the top to mass of the neutrino is 10 to the 12, and mass of the top quark to the mass of the electron is 10 to the 6, whereas mass of the top to the mass of the W is 2, and mass of the top to mass of the Higgs is 1. A question is, do we have a theoretical understanding of why these ratios occur? Not just this. I think, as I told you, the same issues, same laws of particle physics, to some extent have relevance along with other things to understand some questions in the history of the universe. And this is, for example, a sort of pictorial representation of the history of the universe, that the universe was produced in a Big Bang. Then after about 10 to the minus 32 seconds, in early something happened, which we call inflation, after which the universe started expanding and protons were formed after 1 microseconds. And how these protons were formed in the 1 microsecond, the interactions of protons itself play a role in this. Then from this 1 microseconds, to 0.01 seconds, actually nuclear fusion started, and finally the nuclear fusion ends in 3 minutes, at the end of 3 minutes. And by this time, already one produces the various elements, nuclei were produced in the universe. And then the cosmic microwave background radiation, which is what is measured by experiments like Planck satellite, that is actually something that happened in 380,000 years. And everything after that is inaccessible to us via light. And we start getting lights and stars and galaxies formed at 200 million years after the birth. And now the universe is expanding. And in fact, studying the universe and the signals from the universe from these different time periods, that is today and from the cosmic microwave background radiation, and then try to infer about the processes that happened here before, is actually one of the jobs that we are doing, and trying to get indications of physics beyond standard model from the observations, and connection of these observations with our theoretical considerations is one of the areas of discussion. So the gravitational wave experiments have implications for physics in the beginning of the universe. That is where a quantum theory of gravitation can play a role. Whereas theoretical physicists now have a new playground where they can try to use those data to develop the correct quantum theory of gravitation. Again, I have shown you the same picture here, but now what I have done is that I have shown you the energies of the relevance. It's very similar picture, but I have expanded some part of that picture. And here what I want to show you, how different experiments are going to study some of these epochs. So this is, I told you t to the equal to 10 to the minus 26 seconds. That corresponds to a huge energy, 10 to the 16 GeV. Then when I I also told you about this time of 1 microseconds here, what happened in 1 microseconds, t equal to 10 to the minus 4 seconds. And for example, this corresponds to E equal to 10 to the 1 GeV, few MeVs. And now we start coming closer and closer to lower and slightly lower and lower energies, and further away from time. And then we require, for example, accelerators are the tools which will explore in laboratory what happened in the universe in this period, 10 to the minus 10 seconds after being formed, where the energies of relevance were something like 100 GeV, which is what the energies are here. What happened at this time is something we study in high energy cosmic rays. Then there is this work done there. You almost recreate the Big Bang situation in the laboratory and study what happened at microsecond level in the universe, and so on and so forth. Cosmic microwave background radiation, which is what is being studied in the various experiments, and then the theories of structure formation and measuring today's acceleration of the universe. All this is essentially related, and that's what the current study is. As I already said, LHC will contribute to produce the Big Bang in the laboratory. LHC will try to detect the dark matter in the LHC experiments. And we need to build experiments which will measure the Higgs properties very accurately, and then seek solutions to the theoretical problems as to what keeps the Higgs boson light. So this has implications of planning for future facilities. We make measurements at the LHC and the LHCb of particle-antiparticle asymmetry, which can help us to answer the puzzle of matter-antimatter asymmetry in the universe. In fact, some of my own work covers these last 3 points. I'm not going to tell you that, what details of that work. So there are 2 ways in which this happens. One in which you will increase the energy and try to produce new heavy particles. This is what we thought will happen at the LHC. It has not happened. But another way is to precision measurements of the properties of the known particle. And the recent European strategy for high energy physics has pointed out the necessary steps that the community should take. And that is precision measurements of the Higgs boson and the top quark properties, and the precision measurements of the neutrino properties. So this tells us that the future is studying at the collider through the window of the properties of the tops and Higgs particle, and studying at the Indian Neutrino Observatory the properties of the neutrinos. And the landscape of physics beyond standard model looks something like this before the LHC came into picture. And after just the day LHC found the Higgs boson, many of these ideas in red got completely thrown out, and now we have to explore the remaining landscape of these theories, and that's what LHC now will be doing in its remaining years. And we have neutrino experiments I told you about. I showed you how one can take a picture of a sun through the neutrinos, the dark matter experiments, and next generation accelerators. Theorists are trying to build models for physics beyond the standard model. There are many, many options. They have to be tested both the dark matter and neutrino experiments as well as in the collider experiments. And as I already explained to you, particle theories may provide answers to cosmological questions such as the dark matter, the matter-antimatter symmetry, and the dark energy. The high precision cosmological measurements can constrain particle theories, and the searches at the colliders can prove or disprove a particular particle physics explanation of the three cosmological puzzles. So simultaneous probes into the heart of the matter and into the origin of everything. I hope you people are excited about the enormous possibility of such a simultaneous exploration in the very small, at the heart of a nucleus, at the heart of an atom, and the explorations at the edges of the universe and at the beginning of the universe. So indeed, life is very, very exciting, and we all think that there are exciting time ahead. Colliders will actually do their bit by precision measurements, either at the hadronic colliders or at the leptonic colliders. The road is very, very long, and there are many, many miles before we reach the goal, the sun, but it is going to be an interesting journey. Thank you very much for your patience and for listening to me.
Thank you so much, ma'am. It is indeed an honor to listen to your talk. So we have a couple of questions. Shall
Yes.
I ask you?
Please do.
So the first question from a participant is, what can be the relation between Higgs boson and Big Bang theory?
Yeah, now I will have to give you 2-hour lecture, right? What can be the relation between the Higgs bosons and the Big Bang theory? Because there is not a direct relationship. I mean, if I knew that answer exactly to be given to you in 2 seconds, then in fact, I would go and already book my tickets to Stockholm. Okay. But okay, jokes apart, the point that I was trying to convey is there is a very complicated road by which I can make that connection. We don't know the exact connection. That is the whole beauty of it all. That the same experiments which found the Higgs boson, it is not the Higgs boson that's going to tell me what happened in the early Big Bang. But the Higgs boson has confirmed certain framework, certain mathematical ideas underlying the theory of everything, underlying the theory of particles and their interactions. And Higgs boson has confirmed some aspects of that theory. And now the question is, we are surely we know that this has to be amended. This has to be extended. At least that's what I tried to do for most of the talk, to try and tell you that these structures have to be extended. And how those extensions will leave that clue on the properties of the Higgs boson is something we theorists have to work out. And indeed, there are thousands of people, 500 of people who are working on this. So I don't think that unless I explain to you what the theory of the Higgs boson is, I can so lightly explain a question like this. So I'm not avoiding to answer the question because it doesn't exist. I'm simply avoiding it because I do not think I can answer it in 5 lines.
Thank you, ma'am. So, thank you. So the next question is from Arun Gargi Raina, ma'am. What changes in technology are required to explore further experimentally in this field?
No, that's a very good question. I mean, for example, I mean, to tell you, for example, what's happening. And I will take the example of LIGO, which is the Interferometry Gravitational Wave Observatory. Okay. And as some of you may have read, I hope you have read, some of you have read, it was the technological development of measuring very small displacements using lasers by laser interferometry that was required to confirm a prediction of the existence of gravitational wave which came from Einstein's theory. Now, currently, for example, the technology allows us to, once the gravitational waves are detected, it allows us to identify what region of the sky around us it came from. And that's a very wide, big region. And if we can increase the sensitivity of these interference experiments such that they can measure the even smaller displacement. See, right now they are measuring a displacement of the order of 10 to the minus 18 centimeters, which is smaller than the size of a nucleus. And we will have to increase that sensitivity by 1 or 2 orders of magnitude more, so that we can test, for example, the theoretical ideas about black holes, how their mergers take place, what is the number of black holes, how did, there are different black holes in different mass ranges get formed from different origins, how neutron stars become black holes. Okay. Now, for example, for the person who asked me the question, how LHC experiment can study Big Bang, for example, a neutron star becomes a black hole. That happened, and sometimes it happens in Big Bang, sometimes it happens much later, of course. And now, how does a star become a black hole? Okay. In understanding that, you study it from gravitational waves, you get some understanding. But in case of neutron stars, you can understand the same things by doing experiments at the LHC, because you create that Big Bang-like situation at the collider for an extremely short interval of time. So all this, I started answering technology and I moved on to this. But what I'm saying is that if you make that improvement by a factor 2 orders of magnitude or 1 order of magnitude in the size wavelength that you can measure, indeed that will add further to the understanding of gravitational waves, and therefore understanding of how black holes get formed. That in turn means how neutron stars become black hole. So you see, it's not one way. So here you're basically seeing that how improvement in technology, it increases the kind of questions you can start asking. So I hope I have answered to some extent Gargi's question. For example, Gargi, the other thing is that in particle physics, we have the kind of technology improvement that happened, and that happened in the late 20th century, between 1970s to 2000, was measuring particles living, traveling for 10 to the minus 16 centimeters before they disintegrated. And now we are able to measure and the distance that a particle moving at velocity close to light will travel in 10 to the minus, time it will take, 10 to the minus 17 seconds, you can calculate, no? Because you know the velocity of light. So these are distances of the order of a micrometer. And you are able to measure distances of a micrometer in a collider experiment, which is 50 huge, with about whose height is that of an Eiffel Tower itself. That's a few hundred meters. To measure a distance correct to a micrometer in a distance of 100 meters, you can see what kind of accuracy that means. So what you design for that, for example, is small membranes. You may not think that when you are looking at nanotechnology and you're designing your MSME, small membranes and how they move and how motion can make them move, you may not understand at that time that such technology then finds its place in a gigantic experiment like so. So developments in technology in that sense are extremely of being able to measure small intervals of time, being able to measure small distances, are extremely important.
Thank you. Thank you, ma'am.
So all I want to say is that engineers play actually an extremely important role in many of these experiments and possibility of making many experiments a reality.
Thank you.
Thank you
Thank
so
you
much.
very much.
Thank you, ma'am. We also have a couple of questions more, but due to time constraint, maybe I'll send it to you if you can
I will
write it back.
do
Yeah.
that. I will do that.
Yeah. So thank
I
you
will.
so much.
Okay.
Thank you so much, ma'am.
Yeah.
Yeah.
So, thank you, Dr. Rohini, ma'am, again for accepting our invitation. Thank you very much, ma'am. Have a good day.
You too, and good
Thank
luck
you.
for your rest of the program.
Thank you,
Thank
ma'am.
you very
Thank
much.
you. Yeah.
Thank you
Bye.
so much.
Bye.
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 I think we can start the next session. Dr. Mudrika, I suppose you joined.
Yeah, good afternoon. I'm here.
Yeah. Hi, Dr. Mudrika. So can we get started?
Absolutely.
Yeah.
Just that my camera isn't working. That's all right.
Yeah, that's. Yeah, it's it's saying it's not working. Yeah, that should be fine.
All right. All right.
Yeah,
Thank you.
yeah. Thank you, Dr. Mudrika, again for accepting this invitation to give a talk at this event. May I request Dr. Shakti to introduce Dr. Mudrika. Thank you.
Hello, everyone. It's a pleasure to have Dr. Mudrika Kananwal, Associate Professor at Department of Material Science and Metallurgical Engineering, IIT Hyderabad, today with us. So Dr. Mudrika obtained her PhD from the University of Cambridge, UK in the year 2013, MTech and BTech from IIT Bombay. So her research areas include bacterial cellulose and other natural materials, understanding the structure, mechanism, and applications, high performance green composites, liquid crystals, and self-assembly of rod-like entities. Also, fiber spinning, strategies for developing anti-fouling and antimicrobial materials, materials for tissue scaffolding. Her work has received the Gandhi and Young Technological Innovation Award in 2016. To add more feathers to her cap, she is also nominated and elected fellow to Indian National Young Academy of Sciences and member to National Academy of Sciences India. Recently, she has received the prestigious Young Engineer Award from Indian National Academy of Engineers and National Academy of Sciences India, Platinum Jubilee Young Scientist Award as well. So we welcome you, Dr. Mudrika. The session is yours. Thank you.
Thank you so much. I hope my screen is visible.
Yeah, it is.
Perfect.
Yeah.
So, good afternoon, everyone. And first of all, thanks a lot for inviting me to talk on International Day of Women and Girls in Science. And I must also congratulate for putting in such a nice array of speakers. And I mean, really inspiring for all of us, and I'm sure on the other side also. So I have kind of prepared it, a presentation here where we can talk about general problems in our everyday life and how scientists and engineers can try to crack them irrespective of the background, but with a lot of collaboration. So my group at IIT Hyderabad, we are quite committed to the sustainable development goals, and in particular the goal 2, 3, 6, 13, and 14. If you haven't already, you must check the SDGs, and of course what India, the nation, is looking for, so that we can try to align our research along the direction and try to contribute that. It's not obviously mandatory, but for those of you who are interested. So today I thought I'll talk about fermentation derived cellulose for health and environment. Fermentation is a very, very common word because we all make curd at home, we all make yogurt at home, and there are lots of other things like idli, dosa, all these products coming out of fermentation. So I'm talking about the same fermentation, and for health and environment, how we produce a material using fermentation. So my background is all metallurgy and material science, and it might come across to you that I do a little bit of biology, but I'm quite at interface. So let's get started. I thought I'll tell you a little bit about myself. I was born in a small township called Nagda, which is a Birla Grasim township, and I have seen engineers all around me since my childhood, but obviously I had no idea what engineering or science was. My parents, they are settled in Jaipur, the pink city. They're both doctors. So yes, had exposure to science. Um, I came down to IIT Bombay for doing my BTech and MTech, where I first had a chance to really know what engineering was, because before that it's almost always a rat race. Then I went on to do PhD at Cambridge and came back to IIT Hyderabad and thought I should contribute to our own country. So what I've been doing so far, I'm not only a scientist who's interested in various research interests, but I also am a kind of technopreneur. One startup which is looking at recycling of polystyrene, and another one, herbaceuticals. On herbaceuticals, we are funded by BIREC, and I'm very keen on looking at pedagogy, the interventions on that. Anyhow, that's about me. The question is, as a scientist, as a researcher, as an engineer, how can I make a difference? So, when I came back to India, I had two things on the top of my mind, back of my mind. One was female health, and one other was food shortage. And none of them originated from my own PhD problem, but just that I was little concerned about these two things. Female health in particular, because I saw there's a lot of female undergoing a lot of infections. I also went through a bad phase, so I thought there is definitely a materials intervention needed there. Food shortage, because we talk about people dying out of hunger, but we are an agriculturally rich country. So what's happening in between? And then once as a researcher, you identify a problem. Of course, there is research and development. There is it have to make it market ready, and then you have to commercialize it. And most of us researchers, we try to stick to the first two things. Yeah, we rarely jump onto the third point. But I thought on this day, I will also try to emphasize that we must also make attempt or join hands to translate our research for the benefit of mankind. If it is that, of course, fundamental research is also very important, but wherever whatever we can contribute, we should try. So the two things I want to talk about today are food packaging, as I mentioned before, uh, shortage of food. So as I understood, lots and lots of fruits and vegetables are wasted in the country because of infections. So one of the simplest intervention is to create an active food packaging material. And we were able to invent a material which can keep tomatoes fresh for over 30 days. I will talk about it. The second thing I want to talk about, perhaps the first thing I want to talk about after this, is how to use herbal formulations or Ayurvedic knowledge with a modern material science avatar to solve the issues of infections. First, let me talk about the material that mostly we work on, and that's also connecting the things between the connecting material between these objectives. Cellulose, many of you might know it's a polymer. Trees are full of cellulose. The most common source of cellulose are the trees and the plants. However, the cellulose is also produced by certain sea animals, fungus, algae, and certain species of bacteria. The problem with getting cellulose from trees and plants is that it's not available as a pure material, and you must do deforestation. You must use a lot of chemicals to extract cellulose from it. The good side is, of course, the abundance. So here comes the advantage of making cellulose from bacteria. It's very simple. Take any fruit juice, apple juice, mosambi juice, sugarcane juice, any juice, coconut milk, ferment it with the right kind of bacteria, and voila, you will end up with getting a nice hydrogel, a nice hydrogel. When I say hydrogel, I mean to say a gel which comprises of water. Okay, so it's a cross-linked polymeric structure which has a lot of water in it. And when we look at the microstructure using a scanning electron microscopy, these are made up of small nanofibers, which are highly crystalline. When I say crystalline, of course, most of the time in polymers, we don't imagine crystallinity, but these are highly crystalline polymeric nanofibers. These are 100% pure. These are three-dimensional connected networks and biocompatible, highly porous. And thus, it makes it a wonderful material to carry active ingredients. At the same time, because we are synthesizing it in the laboratory, tabletop, it gives us an opportunity to engineer the property. So these are the certain advantages you have of this material over the trees and plants. So today I thought I'll talk about 4 very small stories based around this material, which broadly comes under the theme of health and environment. Let's move on to the first story. And I will not talk more than maybe 20-25 minutes at the most. And then questions would be better. We can talk a lot. Fungal infections are very common, be it in vagina, be it on skin, be it on nail. Athletes and soldiers, they have resistant fungal infection most of the time because they have to wear shoes in humid and hot conditions, which is not good for which is not good for us and very good for the fungus. So while these infections are very common, of course, there are treatments in form of gels, creams, powders. The problem is that they have low residence time. So if you apply a cream, it gets washed away, or it nudge against certain, you rub the surface against something else, you have to apply it again. So they have low residence time and hence require frequent application. In addition, as you apply these medicines again and again, the fungus will create or develop a resistance to these drugs. There'll be recurrent infections, and many of these things may not be good for pregnant women or even in some immunocompromised patients. So what I thought, at least at that point of time, I was also pregnant, delivered a baby, and I came across some of the routine home practices where you use ajwain and fumes to disinfect the mother. Still, those traditions are there. So I thought, can we use the old knowledge about herbs and material science to create a solution for this problem? The advantages being, when you use herbal solutions, um, they're believed to have minimal side effects. Because most important is that they have multiple mechanisms to kill the fungus. So the resistance by the fungus will not be easy to be developed. But the problem is, if you apply them directly, these are thermo and photosensitive. They require a carrier to protect themselves and to control the delivery. And that's where I thought, as a material scientist, as a metallurgist, can I contribute? So what we came up was microcapsules, which are loaded with oils and then put into bacterial cellulose nanofibrous matrix to create a drug delivery system. Okay, so just the takeaway from this slide is, there are infections, these are resistant, we need alternative solutions which have multiple mechanisms like herbal essential oils, but they are sensitive. They're put into a vehicle called microcapsules, and voila, the drug delivery system is there. Now, which oils should one choose? I thought I'll take you to the whole thought process that was there in this project. So we chose the oils of clove, long. We chose the oils of tulsi and oregano. So thymol, eugenol, and carbicrol. We use them in combination to see if A plus B gives more than A plus B. That is synergistic effect. Why? So that we can have minimal usage of oils. So what we did, for those of you who are chemists or understand a little bit about suspensions and solutions, oil droplets obviously would not mix with water. So when you try to make an emulsion, you need a surfactant. Once you have emulsion ready, we put the polymer around it, harden it, and then remove all the extra things, and you end up with microcapsules. So these microcapsules were then tested by putting them into a bacterial cellulose matrix. So this is what the composite looks like. You have nanofibers in which the microcapsules are very nicely embedded. And when we do the release studies, what I mean to say, how much oil is released with respect to time. So this is the graph that we get. The release of oil is much slower, the red curve. It's much slower in case of composites as compared to just using microcapsules. And of course, very much controlled in comparison to using the oils as such. So we observed a sustained activity for 8 hours in SVF, that is simulated vaginal fluid, because we wanted to target mitigation of vaginal candidiasis. Then we went on to understand the mechanism of release. So if you look at this cartoon, there are orange balls with green ink on it. So orange balls are the microcapsule, green is the drug that is coming out of it. In this case, the drug is the essential oil. And of course, you can see white, which are the nanofibers. So there's a double barrier release. What do I mean by that? The oils have to come out of microcapsules, and then they have to travel all the way outside this matrix to be available for therapeutic treatment. This is what leads to sustained delivery. Now, how is this formulation useful? So I'm cutting onto the science and engineering a little bit, but I thought, let us see if this kind of formulation is at all useful. So one can spray them directly. One can put them into foot soles, shoe soles, sorry. You can make patches out of it. You can put them into panty liners or sanitary napkins. There are lots of panty liners now emerging in the market as the acceptability for this product is increasing in Indian market. However, none of them target fungal infections. And therefore, we see that this problem indeed exists and the solution indeed doesn't exist. So then we also went on to understand the quantum of people which would benefit from it. So if you look at Indian population, which is 1.3 billion, and if we look at urban females residing in urban areas, it's about 187 millions. And out of that, menstruating age females, for two reasons, they're more predisposed and second, more accepting of this solution. 118 million women out there need protection. So that's how, we concluded this story. It started with a personal experience of a problem and tried to solve it from my background of engineering. And now we have incubated this, and we are also trying to do a technology transfer so that we can translate the benefits of this technology to a lot of people out there. Let us come to the second story, because the previous one was to do with delivery of oils. I thought I'll talk a little bit about science of delivering drugs, water-soluble drugs. And the reason behind telling this is pain. We all have experienced pain, right? Some of us might be having pain right now sitting in front of the laptop, neck, back, moving legs. So chronic pain and acute pain are parts of our lives. And many of us are apprehensive, obviously, to pop in pills, but many of us are okay. We say, well, I want to be happy. I want to have a comfortable life. I don't mind taking another pill or something, right? But in these situations, one of the better solutions is to directly make a patch at the local areas where you experience pain, if at all possible. And in order to come up with those painkiller patches, there's a lot of complex chemistry, complex material science that goes into it. And many of those methods, even if they're effective, may not be environmentally sustainable. So we thought, can we do something in that direction? So as I mentioned before, bacterial cellulose, it's a hydrogel. That means it has a lot of water. We can dry them by different methods. Two of the methods that I've chosen here are freeze drying and oven drying. What do they mean? In oven drying, you're simply leaving the material in the oven at about 50 degrees centigrade and let the water evaporate. And you end up with a morphology which is very compact and like this. But if you go for freeze drying, what does it mean? We freeze our samples. So basically, you convert your ice into so water into ice and then sublime it without going into liquid phase. So we get a much more open structure which looks like this. So same material, two different microstructures by a very simple method of drying. So one is more porous, one is less porous. One is more flexible, another one is less flexible. Now let us look at what effect it has on drug delivery. So both were loaded with diclofenac. Diclora, popular brand name. Diclofenac is the painkiller. Both were loaded with diclofenac, and see the release profiles are quite different. So if you look at the black curve, the release is much higher as compared to the red curve because the black one comes from freeze dried sample, which is much more open. The oven dried is much more compact. So here is a strategy by which we can simply tune the release of drug to target either chronic pain or acute pain. And then we went on to study how the mechanism is to understand. So one thing that we understood is if this is your hydrogel, as you dip it into a fluid, slowly it gets swollen, the drug is becoming available, it comes out slowly and slowly. And this process is much more evident or much more reflective in case of oven dried samples. So let's move on to the third story, the second last story for today. So in the first two stories, I have highlighted on how by simple engineering, we can intervene into a completely different domain. For example, here drug delivery, therapeutics, because the disciplines carry their own knowledge. And today it's very, very essential to talk to each other, to collaborate. Let's come to the third story of active food packaging. And let me highlight a few facts here. We are 103 in global hunger index. We waste about 16% of fruits and vegetables, which may amount to 92,000 crores worth of losses. And why? Because we do not have proper affordable storage mechanism or refrigeration. And of course, refrigeration would be an expensive choice too, cold chain and everything. Nowadays, there's a lot of change in the laws and there's a lot of agitations that are going on with its own benefits and so on. Anyhow, as a material scientist, the question here is, can I do something about it? So what we did is to create a packaging material, again here, the nanofibers that you see are bacterial cellulose, but you also see some small bright dots there, which are not the stars, but are silver nanoparticles. These nanoparticles are known to be antimicrobial. We must all remember in our childhood or before that, the custom of drinking water from silverwares or copperwares and so on. All that is to do with pure water because they have antimicrobial properties. So we created a packaging material here with less than 2% silver. Why am I emphasizing on the amount? Because lots of nanoparticle can also be toxic. So it's important to be within the range of that. And when we did this trial on real fruits, I'm a believer on trying it on the real thing rather than just laboratory made methods. So we actually tried it on tomato puree, which was actually decayed for 21 days. And then we tried to kill the bacteria and fungus which are present there with this material, and it was successful. And so ultimately what we did, we wrapped tomatoes with three types of materials. The center one is our material, the right one is from a popular online fruits and vegetable supplier. The left one is normal polythene bag, and we can see the decay and wrinkling. The tomatoes with this packaging material were fresh for over 21 days on shelf without any cold storage, without any refrigeration. And not only that, this material is also biodegradable. And now we are taking this work forward with the help of a company called VIT. But we think it's a very important intervention looking at improving the shelf life of fruits and vegetables without hampering their nutrition. That's also very important. So let's talk about the last story. One thing, if you remember, I mentioned that it's like making curd at home. So when you make curd at home, you have the whole flexibility in your hands. You can try to change its texture. And similarly, when I grow my bacterial cellulose, I have a lot of tunability in my hands. So what we did here, with a colleague of mine who has a patent on recycling polystyrene, they make these kind of fibers from polystyrene. Polystyrene, basically thermocol. So waste thermocol, which is a big problem for environment, and that's why recycling is important. So microfibers made out of that. This was put into Petri plates, and the bacteria were allowed to grow around it. And what we get after that is a composite of two types of fibers: bacterial cellulose fibers and polystyrene fibers. And another interesting thing to note here is bacterial cellulose likes water, but polystyrene is a hydrophobic material, meaning it doesn't like water. So given this, one of the very interesting applications that can be used is purification of oily water. So this is an emulsion of oil and water. If you pass it through polystyrene fabric, being the pore size are big, we do not really get separation. If you pass it through pure bacterial cellulose, we get clear liquid, you can see here. If we pass it through our composite, then also we get pure liquid. But the advantage of this one is the efficiency is better. We are able to recover 75% water and at a faster rate. So the mechanism B, because it's a combination of hydrophilic and hydrophobic, it allows a continuous passage of one kind of liquid if it is pre-wetted with that liquid. And also optimal pore size is present there. So let me summarize what I showed today is a problem that of vaginal candidiasis or other fungal infections to create a technology at the interface of Ayurvedic knowledge and material science, to tune the drug release without using complicated chemistry or complex agents, active food packaging to preserve fruits and vegetables for a long time. Another interesting inputs I got on this was to how to preserve fibrous fruits and vegetables, because that is very good also for the diabetic people. And last one, oil water separation using a green method of making a composite. So I want to thank all my group members, all the funding agencies, some of the research highlights in the newspaper, some of the recognitions from the ministry themselves. Let me conclude with a story of a frog and a well. So we women, we are always kind of told this job is not for women, this is not for females, right? Think about it. And slowly we also try to find a comfort zone, right? Have a 9 to 5 job and kind of things. But anyways, putting that all apart, today I thought I'll do a technical talk, but I couldn't resist on sharing this story. So there was this frog, a group of frogs who used to live in a pond. There was a pole in the center of the pond, which was very slippery. The frogs would go, try to climb up, fall down, go and tell people that no, don't try that pole, it's very slippery, you won't make it. So this another frog will not try. So slowly this word spreaded, yeah, and people stopped attempting to climb the pole. But there was this froggy which made it to the top. And the question here is, why did he keep trying and how did he make it? The answer is, he was deaf. He was deaf so that he doesn't get discouraged by listening to others over only giving people a negative impression. So let me just close here with a statement here that let us be optimistic. Let us try to contribute as a citizen, and then obviously the things will follow. Thank you so much.
Thank you, Dr. Mudrika, for this wonderful talk. It is indeed very exciting to see that your research is benefiting a lot to the society. So we have a few questions. Dr. Nirmala.
Good afternoon, Dr. Mudrika. I just have a couple of questions.
Yeah.
You have been discussing about the oil microparticles.
Yeah.
Did you face any problem with the stability of those microcapsules, not microparticles, microcapsules?
Right. Yeah. So there is a lot of optimization that has to be done with respect to concentration of surfactants, which polymers we choose, how much is that. So it took about 1.5 years, 2 years of optimization ultimately to get to a stable microcapsules. Now we have done the stability study and they're pretty stable.
And also you were discussing about the oven-dried and freeze-dried bacterial cellulose loaded with drug. When you go for oven drying, will the temperature not affect the drug, the effectiveness of the drug?
Yes, you're right. So actually, that's why we also did tests at. So not only drug, it also affects the morphology of bacterial cellulose itself also. So 50 degree we found to be good enough for our work. And now we are trying to also we did FTIR after this to see the denaturation and then all those things. So drug is fine at 50 degree. Yes.
Yeah, and the last question, the food packaging application of bacterial cellulose with AG nanoparticles. Definitely there will be a question about the toxicity. How are you going to manage with these issues, toxicity issues?
Right. So we already got a lot of questions on that actually. So the thing here is, one is we are well below the permitted limit. We are only using 2%, which is very low. Second point is we are now doing the cytotoxicity studies of the packaging material. So let's say a tomato is wrapped around with this packaging material. Now this tomato will also be tested to have any type toxicity and the packaging material itself too.
Okay, thank you.
I had a question. Can I ask?
Yes, please.
Yeah, your story about the patches in which you introduce the drug. So does it also depend on whether the particular drug of choice is, can penetrate through the membrane or the skin where you're applying?
Right, it does actually. So we are now trying to see how hydrophobic drugs, for example, would have a very different release profile. Because this bacterial cellulose itself is a very hydrophilic material. So it has a good interaction with those drugs. So now we are trying to see with hydrophobic drugs. And I mean, you're right. Some of these we need a carrier to have a better skin penetration. And all those things are underway actually.
Okay. Okay, very interesting your talk with these simple methods. Very
Thank
interesting
you so much.
indeed.
Thank you so much.
Thank you, Dr. Mudrika. I see that you have typed answers for the questions in the chat box as well. Thank you so much for that.
Yeah, I thought in the meantime, I'll just put the answers. Yes.
Yeah, thank you so much.
So thank you once again, Dr. Mudrika, for this wonderful presentation and gracing the occasion. Thank you very much.
Thank you so much for the invitation.
Yeah, my pleasure. Thank you. Yeah, bye. So we move on to the next session. I think Ida, you have joined.
Yes, I have joined. I'm here.
Hi, Ida. This is Nirmala Grace. Yeah, nice meeting you. And this is my team sitting over here organizing the event. So can we get started?
Yes. Yeah. Can you hear me okay?
Yes, perfect, Ida. Yeah.
Okay.
So,
can I share my screen?
Yes, yes. Yeah, before that, Dr. Shakti will introduce you, and then you can proceed for your lecture. Thank you. Thank you, Aida.
Hello all. I'm so happy to introduce Dr. Aida Todri Sainian, who's going to speak on the topic, the world needs science and the science needs women. So this talk seems to be like a wake-up call on this special day. So to talk about her, Dr. Aida is working as a director of research in CNRS. Her research activities are focused on modeling and simulation of nanoscale devices and interconnects for advanced CMOS and emerging technologies. 1D, 2D nanomaterials such as 2D TMTs, carbon nanotubes, nanoribbons, polymers, composites, design of biomedical sensors for wearable health monitoring applications, quantum computing, and neuromorphic computing for AL and monolithic 3D integration. The list is long. She expertises on her expertise are on physical design, design space exploration, and optimization methods for energy efficient circuits and systems. She has published over around 100 research articles in various peer-reviewed scientific journals. She's also a visiting fellow at University of Cambridge, Ulfson College. Dr. Todri Sainian was a recipient of John Bardeen Fellow in Engineering in 2009, CNRS Prime D Excellence Scientific in 2012, ACM Distinguished Speakers 2016 to 2018, CNRS Bronze Medal in 2016, and ACM SIGDA Meritorious Service Award in 2020. So we can't wait more. So Dr. Aida, we welcome you to deliver the lecture.
Thank you. Thank you so much for the introduction. And I would like to thank you, and I'm honored to be here today. So it's a very special day. We need to celebrate women in science. So this is the right place to also bring a little bit of awareness that we need more women to be implicated in science, and their role matters, their voice matters. So I'd like to share a little bit my experience, maybe also to bring awareness on some key factors and some challenges, barriers, and maybe a little bit of some takeaway message on what we can all do to improve and to also get more girls and women in STEM and women in digitization, especially now in digital age. So without further ado, I will start with a little bit of an introduction to who I am. So indeed, I have done all my education in US, but I'm born in Albania. So maybe for some of you might recognize this very little country in the south of Europe. And it's one of the low income countries in Europe, and very small as well. So education was the only way to progress and to have more opportunities. So I was instilled with that mindset that education is the only ticket in terms of progressing oneself and also going further and having more opportunities. And I excelled in math and in science at a young age, and that allowed me to have fellowships in order to be able to study in US. So that's why I have all my degrees, undergraduate, master, and PhD in US. And also it allowed me to have some work experience in industry in various national research labs in US and also in Cambridge more recently. But I would like to also bring this in the saying you probably know, Mother Teresa, which has been very much implicated into the role and also protecting children in India, where one of her famous saying that I very much resonate with is, alone I cannot change the world, but I can cast a stone across the waters to create many ripples. And the idea here is the same, that we need to bring awareness to our cause. And our cause is women in science, because in underrepresenting women, it also means we are also underrepresenting the solutions that we can find to the global challenge problems that we are facing now. And with that context, I would like to also say a few words that indeed what my research over the years has also shaped out to try to address or to try to have some impact with respect to some of the challenges we are facing. So my research is into energy efficient computing, and I look at it from materials, the physical properties, how we can actually build devices and also understand their physical behavior, how to interconnect them to build circuits and architectures that are low power. Power is an important challenge, especially in electronics, and given their very large number now of proliferation of all of this electronics in our everyday life, and especially also in the cyber physical systems where we'll have more and more connected systems. So it's important to reduce their power because overall they have a huge impact on overall energy consumption, energy production, and also the data use. So I find that over the years, my research has been shaped to address this problem from the materials to devices to circuits and architecture. And can we do better? Continuously asking the question, can we think them differently? Can we rethink the way we design? And so that has been sort of my main focus, and also my main drive through to explore various different paths. And I have built a team, and I'm very happy to see that over the years, I have worked with brilliant, fantastic women, and I have currently also in my team postdocs and master students and PhD students, and a very well diverse team. And I'm also part of this locally. We have Femmes en Sciences, which means women in science in French, where there are these fantastic women. We share their time to mentor, to sponsor, to coach students, to be able to share their experience, to support them. And it's difficult sometimes as a student when you find yourself as a minority. So having this ecosystem, the Femmes en Sciences in Montpellier has allowed to also strengthen us as women. So we have the support, but also to support the young generation, so the mentees. So we have young students from various fields, so in science, that we mentor, and I'm part of this mentoring program where we coach, we supervise, we provide the professional support, and also how to help them to navigate this career path and also what's beyond the university. So this has been a very rewarding, and also has provided me more confidence as well to know that I belong. I am part of an ecosystem that has the same vision, that's want to support women in science. And that kind of brings me to what is happening globally. Globally, we see that I found the statistics from the UNESCO source where you can see that the Central Europe and Eastern Europe has at least the best percentage of women in research. That's 47%. So that's a nice number to see up there. But you can see the rest of the world, we are still far away from the 50-50 or having more women being part of the research community. So we have a significant underrepresentation on various parts of the world. And even though bringing awareness is having some fruits, but we need to keep up pace. So there is still more awareness, more support networks that we need to bring in. And every institution from public sector to academic, but also to private sector to further into the working environment. We need to bring in this cultural change that women are part of the solution and their voice matters. I would like to bring a few statistics before I go to share a little bit more at least my career path so far. I'm in the midst of it in my mid-career, but it's interesting to see also where we lose the women, where women are missing in terms of from high school. You can see that we have about 50-50 almost. So here in orange and in yellow and in red is showing the percentage of women. So Asian women, minority women, white women, and also foreign temporary resident women. And you can see that at high school, we are about, we have a good mixture of boys and girls. And by the time they go to college, you can see that we are starting to have a little bit of still this at the beginning, we are still having this good mixture between boys and girls. But by the time we have the graduate degree, so when they have a bachelor's degree, we can see that the women are, the number dropout is drastic. And by the time to master's degree and further to a PhD degree, you can see that this is further the shrinking. So we have less and less women. So at the start, we have a good representation, but at the end of this academic path, we have a very large percentage of dropout. And it's important to understand what is causing this. from both an institutional perspective, but also from the academic environment. What can we do better? Can we program? Can we design classes or courses a little bit better to be more welcoming to women? And if you see a little bit more by degree, by the engineering degree, even though in chemical and biomedical, we have a very good representation of women in terms of percentage, but if you can see in mechanical, electrical, in all other type, we are, minority. We are in 12 to 20% representation, which shows that we can do better. There is some work there to be done, especially when some of these fields are considered as male domain fields. And if you look into computing, so computer science, information science, software, we can see that in software, we have a very good representation of a female with respect to what is happening in more traditional computer science. That's also something that over the years is starting to progress, but still at a very slow pace. That means software has, because of its very open and programming and coding, is making some impact to have more girls to be part of this, but still we are far between this parity or 50-50 parity that we would like to attain. And this is an interesting chart that I thought to share. So what happens to women? So look into the years after they obtain a diploma. So by the time they obtain a diploma, we have this very good representation of engineering of women and men. And look what happens after years. So that means that as further they go into their career, we see there are less and less women with this background, in engineering background, they are in the workforce. So there is also some problem toward what happens after graduation. So what is happening in terms of workforce, or if they go into an academic environment. So it seems like we have a little bit of an institutional problem to maintain women in engineering throughout their career paths. I'm also part of the European, so in the European Commission, there is a lot of effort to also have some statistics in terms of women that are involved in ICT, which is information, communication, and technology related fields. And even though we have a very good participation of women that graduate in EU, what is happening in ICT fields that continue to work, you can see that is about 13%. So again, there is this very narrow pipeline that we are seeing, and there is a leaky pipeline. And what we are also witnessing, that there is an impact of all of this dropout effect that we are witnessing. And if you look at it by country, some countries like Spain, or at least the northern countries in Europe, are very well represented of having these women being part of so women scientists and women in research. But there is still some efforts to be done. You can see here in orange or in yellow or light blue that this, is still in some countries, there is still some effort to be done to have more women in science and engineering. So the question comes now, what we also studied, it's very interesting to see, at least in the European context, that women in the digital sector tend to leave it. So they drop out at a much greater rate than men. And this is between ages 30 to 44. And this is also when most of the Europeans have their first child, or they take care of small children. And the drop off is about 1.2% for men, and a drop off 8 points for women. So there is much drastic dropout for women. And this is a very also sensible age range, because in the same time you are taking care of small children, but also maybe you will have some family responsibilities for aging parents. So there is this very sensible age range where most of the women feel compelled to drop out. So this dropout phenomenon, we also have some estimation in terms of economic cost in Europe. And we see that some estimations show that the annual productivity loss in the European economy due to the women leaving their digital job is about 16 billion euros. So this has a very big impact in terms of economic, but also educational, because some of these women are part of the academic environment. So it's also causing this chain effect, what's happening to the next generation. And so it's a very interesting to see that being underrepresented has not only educational, but also economical impact. And I like this little chart here, and it's interesting to see that how women, if you look into this leaky pipeline, right? So we saw from high school to graduate, and then to women in careers in STEM. We see that, you know, from high school you have this very nice, as I mentioned, about 50%. So you have boys and girls that, you know, like population, the diverse population. And then by the time they have a bachelor degrees, it's 32%. So we see we are losing some women in STEM. By the time they have a master's degree, we have 30%. By the time they are in doctorate, we have 25%. So already we lost half of the women from high school to doctorate degree. And what happens, we have women researchers about 29%, but on top academic position, and this is where the leaky pipeline gets worse. We have, especially in the career path, we have only 11% of women on top representative or leadership position. And then if you want to look into the Nobel Prize winners, we only have 3% of women. So this is, in a sense, we need to understand what is happening at each stage and why it does get worse during this career path and how we can sustain. And some of them will be both cultural, but also structural. And so some of the causes, which I will also highlight a little bit what our studies show, that is the climate in terms of the cultural, how the, what is the culture, or what are the values in terms of the environment where these women are embedded, so even academic or in an industry. And some of them, it's the demands on the family responsibilities. And also the lack of role models. It comes often again that there is very little mentorship or sponsorship of women throughout their career to be able to navigate. And for some of them, it's their first generation to attend college. And this is an uncharted path for them. So there is also very little guidance they might have had from the family and also from their surroundings. So there is little support, and they also do not know how to navigate. And this is also where the role models can be very important to help to kind of go through this uncharted path from them. So it's an interesting factors. And if we go look a little bit more deeper, we'll see that I think what we see, at least in the European context, that the curriculum program in engineering, so in academic, they are structured such that it discourages many girls and women to be involved in science. So that means we need to look a little bit how we can also outline and also organize our curriculum such that they are more welcoming to women. And there's also this isolation feeling, and I'm part of it too. And well, sometimes you feel isolated, you are alone and there is, you know, lack of support, and you feel like you don't have a voice. So there is very much this cultural barriers that constraints. And sometimes our domains, our scientific communities are very much stereotypical, where there are a lot of all male teams. And the next challenge is also this work-life balance. And this comes often and often again, regardless of where in the world, that there is a lot of pressure from both the work, but also the life and also the family constraints. And some of the academic environments, what we have also noticed is there is a lot of pressure to get tenure, toward full professorship. So there's also the workplace environment that also brings a lot of challenges for women to progress and to continue further on this path. So here I'm showing a few things that what we are reporting on this Women in Digital Age is the leadership, the lack of women representing leadership roles is one of the main challenges, because that also brings this mirror effect that women can associate. They can see an example, they can see a role model, they see how others have done it. So learn by example and also lead by example. And also the work life, this is a very challenging, and I also struggle with that in terms of the having more flexibility. There are sometimes family constraints, so especially when you have young children and they get sick, and daycare constraints. So this work-life balance where we need some support from our also, for example, having a daycare on campus where you can go and see your kids during the break or lunch, or you can see if everything is going well. And on the barriers, what we see is this cultural factor that, as I mentioned, there is a lot of these networks, professional networks, where it's difficult for us as women to be part to fit in, because there is this this old boys club mentality. And so we need to somewhat have this social discussion and be able to see that we have challenges, scientific challenges, but everybody needs to pitch in. And we should open up a little bit, at least level the field, that science belongs to everyone. And I will also mention where exactly some of the key, what would be some of the key actions that we can play and we are actually undertaking that makes a difference. And we'll see this also as we witness over the years. So what are some of these key actions? So what are some of the tools to promote women, and what we are currently undertaking as well here at the University of Montpellier, but also with respect to what the European platform for supporting women in digital age. What we see that the key is to support as early as from childhood to youth and all the way through adulthood, so through the career path. And the most important, 5 important metrics or tools that come out is the role models. It means we really be outspoken about their role and having this leadership role where they also give their example, how they have been through, what challenges they have been through, how they overcame. So to be able to speak about, regardless of the challenges, but to speak that they have overcome. And we need this from early on. So I will also give some examples of what we do here. And the mentoring has to start early. So we cannot wait till they come to university, but we need to start even early from high school and even during preschool. Training has to be a continuous process. We'll see this from childhood all the way to adulthood. Sponsorship, we need to sponsor, we need to give service. And it's one key factor when you have a leadership role to give sponsorship, to give them some responsibility, to say, here, this is something that this person can do, vouch for them. And this is a service that you can do for your students, but also for your community. And lifelong learning. This is a continuous thing to maintain, that we always need to keep our skills, especially digital skills, up to par. And I really like to see that prioritizing preschool through high school is essential. I do not know how this is currently in your country, but here in France, this is something, even in Montpellier, in the university and Femmes en Sciences network that we have created, this is key. We have seen that we are intervening more in preschool and high school. So I also go with little science projects to preschool, where we show, for example, what is magnetism, or what is a volcano, or what is electricity. And this encourages girls and women to be part of the math and science classes later on. So we need to expose them early on to engineering and computer science, and also coding. We have a lot of coding camps for girls as well. And also to promote them to have this active hands-on learning. And I love this little picture here of one of the girls. You know, she wants to be an astronaut, and we need to give more of that kind of attitude. The girls can do it all, and there is no limit. You know, science knows no gender. And so I think encouraging from a young age is very key and critical, and also throughout the university. So as I mentioned, what happens at the university is that we need to design courses that are more welcoming to women. So the environment also, it's not stereotypical. So we need to also rethink how we design courses and the environment and the practices to be more welcoming to girls. And of course, we need to increase awareness to make them know that there is a career opportunities for them. There are pathways to opportunities later after they have a degree. And to continue with these role models, women that are leaders either in academia or in industry. And continuing this mentoring program where they can share, where they can be outspoken, where they can share experience and also see that how other people have overcome the challenges that they have met. So it's very important to encourage women to continue on to pursue engineering and science in the university and even beyond. So how to retain. So I think this is where the biggest dropout that we notice on this leaky pipeline, the retaining women in STEM. And I think this is where it's more of an institutional challenge, because the institution also has a lot of pressure, a lot of challenges, and very little support for women. So we need to promote this, as I mentioned, come key again: mentorship, sponsorship, networking program, and more inclusive and respectful environment, so women can feel that they belong. It's very important that everyone, not only women, has a sense of belonging, that they belong in an ecosystem where they matter. And giving this sense of belonging, this identity, is key to retain women. Otherwise, they will feel they don't make, that they are not part of the cultural identity of the academic environment or industry. So it's very important to prioritize this sense of belonging. And also, something that I also very much I'm part of is this, how to recruit and hire and promote women, especially in an academic environment where we need to juggle. We are scientists, we also have various roles, and also young children in the meantime. So here is, I think, where it's very important that the work environment promotes this, a lot of this flexibility, so women can juggle between family, medical leave if they need to, also to be able to find opportunities to have more flexibility in their work, especially in these critical years where they are at the start of their career and also starting a family. And this is critical. We need to have programs out there and also funding to go with, to promote women, that they can be part, even though that they need more flexibility, or they have some strong family obligations, they can continue to be part of this environment. So we need to have this mindset. We need to continue professional development to be able to support them throughout, but also to have the flexibility in mind. So this is something we are working, and at the university level, this is a continuous uphill battle, but we are making some leeway. We are making progress. We are not all satisfied yet, but we are making progress, because it requires institutional change, but also bias, cultural change. So that brings me to, why does this all matter? Why are we making so many efforts at various levels? So I'm making an effort, as I mentioned, at local level, national level, and also European level. Why does it matter? And even you are making an effort at your level, at different levels, regardless. Why does it matter? Because science knows no country, because knowledge belongs to humanity and is the torch which illuminates the world. And I really like this phrase by Louis Pasteur, which is a French scientist from some time ago that you might have heard about, but this is and it resonates even more now than ever. Science really knows no boundary, and we all need to be part of the solutions, because knowledge belongs to all of us, to humanity. And that brings me in the current context. We have a lot of global challenges, and we are currently in one of the biggest global health challenge that we have ever faced in the last century. So it's important that women are part of these solutions, because we need to unlock the potential of half of the population. Half of the population is underrepresented. Half of the population is not contributing to the solutions for these global challenges. And these are the biggest challenges that we are facing, from energy, from climate, from food, from education, security, poverty, economics, you name it. So we need to have this inclusion. We need to include and have more women represent to target these biggest challenges. And also because supporting girls today would mean supporting and teaching and mentoring the girls of tomorrow. And the chain effect here is critical. And this is why we need more women in science, because we have to find diverse solution, and we need all the brain power, not only half of the brain power of the population. And that brings me to my experience. So I am a mother, I am a scientist, a daughter, a wife, a sister, a friend, a colleague, a mentor, supervisor, and many, many other names. But what I find myself that I am continuously between many of these. So I wish I had many hands and many brains and I could clone myself, but being a scientist has been very challenging for me and very lonely at times, because sometimes I have come up with, I had to take decisions where sometimes you find yourself very much counter stream. but I'm passionate about my science, and that has shaped my world and has shaped who I am and what I do. And I let that drive me as a scientist, but also as a person, as who I am. And I would like to say that science has been a journey, is a journey, which I'm continuing to ride. And the research has been my road in terms of the paths that I've taken. Sometimes I've taken uncharted paths. And the progress and innovation is the destination. Sometimes we arrive into it very late. Sometimes we arrive in it in a very challenging, but it's a pleasure to go through this journey. I had to work very hard, and I continue to do so, and sometimes even to fit in professional networks, especially where they are very male domained. And it has been challenging at times, and it's challenging to also identify role models. But on the flip side, behind all of these challenges and many, I would say, struggling and multitasking, I have found that blazing my own trail, so finding my own path, even though uncharted, has given me the freedom and creativity of my work. Remember, I come from not a scientific background, and I come from a country that I didn't have all of these opportunities that we are offering now. So I had to figure it out on my own from a young age, and then take a lot of the challenges and grow with these challenges throughout. And has given me the window of opportunity to work in various different environments, to see what works, what doesn't work. And I've seen the highs and the lows, but I've also turned these challenges into opportunities to grow. So despite being challenging, I would say that it's a very rewarding, because you grow and you don't know what your limits are till you are tested. So I would also like to share a few personal things. You know, during the conferences, I would go. I mean, when I had my young boy, I would go and attend. I would go with my little stroller, and then after the conference, where people would network and mingle, I would take care of my little one. So it has been very rewarding. I have shared a lot of things with my young son. I've also been, when I was a fellow at the University of Cambridge, he was throughout with me. I spent a year in Cambridge as a visiting fellow at Cambridge Graphene Center. So he has been with me throughout, of course, my husband as well, but you know, to also have my child going through me with my career path has been very rewarding as at a human level as well. I've met many important people, and also I've met the president, which has been one of the highlights as well. And along the way, I've learned also how to juggle motherhood and being a scientist. So sometimes you are trying to write something, but sometimes you need to write, you know, silly things with yours in order to learn how to write successful proposal with your child right next to you. So it has been struggling, a lot of ups and downs, but it's been rewarding, because this is what tests us and what makes us. And my advice, if I have to give a few advice to who is listening out there, is to also have a mindset of confidence. To, rather than having this fixed mindset where you think intelligence is static, that means you have what you have, and you are just simply trying to look smart and avoid challenges, and you give up easily on obstacles and ignore feedback. So that's a fixed mindset, and that's something to ignore. But you need to think that intelligence can be developed. You grow, you learn, you adapt, and you embrace the challenges, and you persist despite being in obstacles. And to see that sometimes these obstacles will make the path to mastery. That's when you become best. And to learn from criticism, how to use that to see the positive side. And do not be threatened by other people's success and to see as a competing, but be inspired. And everybody has their own credit. So have this growth mindset instilled, that even in young girls, that everything can be developed, everything can be evolved and adapted, and you learn along the way. So I would like to maybe wrap up saying that final words: to believe in yourself, and believe that what you do matters in science and in society, that your voice matters, and believe that self-confidence is very important. And to strive to create these networks, you need to find your ecosystem, a sense of belonging, people that you can share, and you can find that support that you need. And to be outspoken, sometimes we need to speak about our challenges and to share and see how other people can also support you. to have aspirations. I think we need to keep our objectives and be courageous and not be afraid and be determined to follow what drives you, your scientific curiosity. And also to be realistic. Sometimes you'll see that people will not see things in your perspective, and that's okay. And in the end of the day, you decide what you're worth fighting for. This is your life. You have to make decisions, and you need to know where to put your energy and what to fight for. So keep that in mind, that there will be challenges, but you will be rewarding as well. So with that, I would like to thank you. And I hope I shared a little bit of my experience, even though I'm in mid-career, but it's important that we have more women in science, because the global challenges are high stake and we need everybody to pitch in. So with that, thank you for your attention.
Thank you, Aida. It was really inspiration. And I agree with many of your comments, being a woman scientist as well as a mother. Thank you very much for sharing your experience. May I request Dr. Shakti?
We have some questions for you. Before that, I would also like to thank you again. I have been writing a lot of points that you have said, especially science is a journey, research is the road, progress, innovation is the destination. I really liked it. So the questions, the first question is there a need to make sure women support women? Why are not women united, and how to bring in a support system in workplace?
Yeah, I think women, this is a key, right? I think the role, as I mentioned, the mentorship and the support is key. I think knowing that there have been other women going through this struggle that can share, maybe will give you tips, insights on how to better navigate, so you have a better understanding of what you're up against. Sometimes we don't share, and I think this is a pity, because we are so much upfield battle. But sometimes sharing actually also helps to get a perspective, and to learn from other people. So we need to have a support. We need to build. So if I can encourage you, is to build your local support. I'm sure at VIT you probably have some support system, and seeing all many bright women here, it's also an evidence that you can all share. And especially when we are at this critical age where you have a career to strive for, a family, and so many other obligations, and we need all the help we can get. And don't be shy to ask for help. I think this has been something that I learned a little bit later, and I wish I knew earlier, to be able to be more outspoken about my challenges. I was very discreet. I didn't want it to create too much hoopla around me, but now I see that by talking, I'm also helping them to talk about their challenges, and maybe I can give advice. So it's very important to have the support. I do not know what is in your local at the campus, but it's an important, so girls can see as a resource where they can get insight, where they can go in case if they have troubles or questions. It can be either scientific or even personal. So it's a very important resource.
Thank you so much. So the next question is, how does privilege work even among women?
How does privilege? So I don't come from privilege, so I cannot speak about that. I come from a very underprivileged background, so I have to work hard to achieve what anything came easy. There are some networks where things can be, there are some networks where maybe things can be more facilitated, because, as I mentioned, the sharing, the support can be stronger. But I still think women in general have very difficult, because we are so pulled apart for many multitasking. I do not know any, at least I haven't met any woman who has it easy yet. I struggle. I struggle every day, sometimes even, pick up from schools and daycares, sick, especially in the current context. It's very challenging. So privilege, I don't think we are there yet. At least personally, I'm not there yet.
Okay, so there's one more question. So do you think curriculum that exists now is framed mainly for the advantage of men?
I think so. This is what we are witnessing, and this is what our research studies has shown. The programs, so the curriculum, academic curriculum programs, are actually not very women friendly. And this is why we also see not many of them incite you to go toward a more engineering program. At least here, what we are witnessing in Europe, in the European context, we witnessing that, and we are making a challenge we are making some efforts to address this challenge. And some of them comes from as early as high school, and giving them a little bit of a preview. What does it mean for women to code? What does it mean for women to be entrepreneurs? What does it mean for women to be designers or architects or different? So we are actually now, even we have built this sort of a panorama with women that have various leading roles, and just for other girls to see that here you have somebody to expose. We need to expose more of this so people can see familiar faces. I think when you see familiar faces, you resonate.
So one last question. What does it mean to be doing science in a premier institute?
But in a what institute? Sorry?
Premier institute.
So I have been in various, right? So I've had the opportunity to study many academic backgrounds in terms of in US and here in Europe. And I think what is the common of all of them is the scientific curiosity. So you'll see brilliant people, fantastic people, but the environment makes a difference. So the scientific curiosity is something common, no matter where you go. So I think this has been very, even in US or in UK, the environment support matters. And I think this is why some students are exposed to more opportunities, to more mentorship, and ultimately to a better career path. But scientific curiosity is something that I see everywhere. And this has been the main driver. And this is refreshing to see.
Okay, so there are more questions. So I would like to take one more question from Dr. Anita Devadas, who is our next speaker. So she asks, what is your opinion on gender pay gap and how to standardize from a policy perspective?
Yeah, that's another thing that I probably didn't highlight enough, but this is also what our report shows. From the European Commission, we see that the pay gap, it's also a big problem at this age range, as I mentioned, this very critical age range. And it's something that needs to be addressed at institutional level, governmental level, also policy. So that's why we need a lot of women lobbying in policy. And but this is something that we are facing, and it's an underrepresented. It's one of the other biggest problem, the economic impact of all of this. We don't have a solution yet, but this is why we need more women to be outspoken and lobbying in policy making.
Okay, actually there are more questions pouring in, so I keep saying last question, but then there's also one more question from Joy Sophia. So she asked, please give some tips to effectively do work-life balance.
It takes a village, a work-life balance. I'm not alone. I have actually a lot of people behind the scenes that maybe you don't see. So daycare, family, nannies, grandma, grandpa, aunts, uncles. And now I don't travel as much because of the given context. And so it takes a full network. For me to do what I need to do, I have a very supporting family. So husband first. You need to choose well. That's one thing. You need to have a supporting husband at home, but also you need the family. And so it's not, so the work-life balance, you need the support. Get all the support to help and to be present. So when you are spending time with your children, you are fully present. So for me, it's a support. It takes a village to raise children. I do not know if that is the same in your country, but for us, it takes a village to raise a child. And you need all the support you can.
Yeah. So there's Akshay. So he's asking that, can even men pitch in helping the next generation in science, and how?
Can women be, say again,
So he, being a man, wants to help the next generation in science, and he wants to know how.
Sponsorship. If I have to give one advice, sponsorship, sponsor women, let them take the leading role, highlight them, give them the opportunity to, I don't know, to be part of in their scientific domain, give them a role, give them a responsibility that they can shine. I think all they need is that platform, and you'll be surprised sometimes how amazing things these women can do. We need to give responsibility because you feel you own. the sense of doing something that has an impact is important. We need a sense of why we do what we do. And the moment you empower somebody here, that can be amazing, and it can take you to places that maybe you never thought before. So I think sponsorship, if you can sponsor a mentor, please, I mean, highly encouraging.
Thank you so much. It is indeed a wonderful talk. I'm very delighted to be with you here.
Yeah.
Thank you.
Yeah, thank you. Thank you, Aida, again. This is Grace here. So thank you once again, Aida, for giving such an interesting talk. And I'll catch you up for the next event in March. Yeah.
Thank you so much for this and for the excellent lineup of speakers. And I hope we'll have to interact in person at some near future at some point. So
sure,
thank you so much.
Thank you. Thank you. Yeah. Have a nice day. Bye-bye.
Have a nice day. Bye-bye.
Bye. Dr. Anita, good evening. Yeah, this is Nirmala.
Hello, Dr. Nirmala. How are you?
Yeah, fine. How are you? Great.
Yeah, good. Thank you.
Yeah, sure. Thank you. So I think we can get started. Before that, I'll just introduce my team. Since I know Dr. Anita, on a personal note, I want to introduce my team. Dr. Swati, Dr. Mangair Karasi, Dr. Shakti, Dr. Vimala. So, I mean, we are organizing this event on women in science and technology, and good to have you here. So, can we get started?
Yeah, that's fine.
Yeah, thank you. So, may I request, Dr. Swati to introduce Dr. Anita.
Thank you. Hello, everyone. So it's a pleasure to introduce the speaker for our next session, Dr. Anita Devadas. She is working as a senior research fellow in the Center for Nano Health at Swansea University. She is also a recipient of CERS Caimro 2 Fellow, and her part of her fellowship is also funded under MSCA co-fund scheme. Dr. Anita has received her PhD in chemistry from School of Chemical Sciences, Biomedical Diagnostic Institute in Dublin City, Ireland. Before taking up PDRA position in 2015 within Swansea University, she has worked as a Brain Korea 21 postdoctoral fellow at Hanyang University, South Korea, and later as a postdoctoral researcher at Tokyo University of Science, Japan. Dr. Anita's research focuses on developing nanomaterial platforms and signal amplification strategies for early point-of-care biosensors with a particular interest in the transduction science, including biofits, electrochemiluminescence, and photoelectrochemical sensor. She has published around 35 research publications in peer-reviewed journals to her account. And with these few words of introduction, I request Dr. Anita to deliver her lecture. Welcome, ma'am.
Thank you, Dr. Swati, for the introduction. And hello, everybody. This is me, Anita Devadas. I'm a senior research fellow and Circumri Marie Curie co-fund research fellow working within College of Engineering at Swansea University. I'm glad to be a part of this event, celebrating International Day of Women and Girls in Science. As a STEM ambassador for Wales, I'm indeed privileged to share my experiences and on my travel from east to west, redressing the balance. I believe all women at any stage of their life in their career, they have been facing loads of challenges thrown at them and addressed successfully in their own way. I see these opportunities like today, it gives us a platform to share our experiences with our peers, which will increase the sense of belonging for women in STEM, which is really challenging and which is what is really needed at this point of time. Women and girls represent nearly 50% of a population, but however, it means nearly half of every nation's potential is from women. But the real question is, are we utilizing them fully as needed to reach our goals? So science and gender equality are both vital to reach any nation's potentials, both in the reaching the scientific as well as socio-economical goals. So over the past 15 years, the global community has made loads of efforts in order to inspire and engage women and girls in science. However, yet women and girls' engagement in or they are excluded from participating fully into the science. So when we just look into this, the recent data, like our previous speaker highlighted, Dr. Ada, the participation of women is still challenging, and the data shows less than 30% of women, or less than 30% of the researchers worldwide are women, and only 30% of the female students, they pursue STEM as their career in their higher education. So there is when we just look into this number of women in education, in higher education and STEM-based career, the number goes down. So this can be explained using the leaking pipeline, as well explained by Dr. Ada. So when we just look into the graph here, when we assume there are 100,000 students in the graduate level, say for example year 10, grade 10, when we assume it's like 50-50 ratios, there are loads of chances for the leakage. And then when we process through the career, getting into first year of engineering, or going doing a master's studies, or even to a PhD studies, the number goes down and down and down. And then when we just look into that, very few people get into that stage. And especially when we just look into the number of women entering into a STEM career, it's even lower than the percentage. So when we look into that one, for example, roughly only 20% of the female are doing their PhDs, and then getting into STEM-based careers. So this is, there are loads of challenges that women face throughout their careers, and most of the women, some of them, unfortunately, they just get trapped into that leakage, and they're not able to come back and thrive back into their careers, and which is really hard for women. And so worldwide there are loads of efforts in order to promote women in science. So when we just look into the the reason behind all these things can be explained through this leaking pipeline, but then we need to understand this leaking pipeline, and we need to understand how to address these gaps that are that women face. I would like to clearly, men and women both faces challenges throughout their career, but then the question is the amount of challenges that women face when they are in STEM career is quite different and quite unique. So I would like to compare the challenges that women in STEM faces, and then I'm just linking it to my personal experiences, and then to share how these challenges can be addressed and what needs to be done to promote more women in science and education. So I'm just giving my personal experiences. So I am from a small town in Vellore district, which is very close to VIT. So I did my schoolings in a government girls high secondary school. And then I did my BSc in physics at Sri GVG Visalakshi College in Udumalpet, and MSc physics in Konganadu Arts and Science College in Tamil Nadu. So when you look into my, when I was doing my master's as an aspiring student, I always wanted to get into research, but then the pathways to research and, was still challenging. So then I came across the summer research program run by IIT Madras. This is a well-known India STEM program to encourage postgraduate students to get into research and get the taste of research. And I was successful in securing the summer research fellowship in 2016, which gave me, nearly 2 months' time to be spent in the labs of IIT Madras, and gained hands-on experience and the taste of research on nanomaterial synthesis and development. This has given me a solid, a taste of research, and then I wanted to pursue my, career in research. And, my academic training, I got through my BSc and MSc physics, graduation, degree. And the research training I got it at IIT Madras has helped me to secure a PhD, position within Dublin City University, in the School of Chemical Sciences. So although when you just look into the graph, I had to move. Mobility is the key thing. I had to move within Tamil Nadu to secure education, which was not that challenging. However, mobility to, after securing an international fellowship and moving to a foreign country was really challenging at that time, because we had no clue about the foreign culture, and we didn't have any contacts in Ireland. So, but only the passion towards my research has fueled my journey. And, I just went to Ireland in 2008. So, getting into, regional disparity is exists everywhere when we look at the opportunities from region to region. Because, for example, in the case of education, when we look into STEM-based educations, it is more populated in the bigger cities. So people had to, travel to the bigger cities to, to gain education, as well as for PhD programs, or if you really want to go into top ranking institutions, it really needs the mobility. And, some of the women are, able to do, accept that mobility, but some of them, it is challenging for them. And once you enter into that one, into that big cities, move into the big cities, adapt the, culture, the cultural differences is, again, plays an important part, because, we won't get everything in the same place. So, we need to understand the culture. We need to, get along with the people. We need to have a broad and, open thinking to adapt to that one. And again, language is a big, is another big challenge, for people who ever moves, outside for their education or for their career, for their job. For example, for me, my spoken English was not that great back in 2008. So I struggled a lot. Initially, it took me nearly 3 months to understand the Irish accent, because they speak quite fast. So, in order to understand that, it took me some time. But then my fellow, researchers and the research group was fantastic, and they helped me a lot. And then they mingled and they took care of me, and then they encouraged me a lot, to learn language and to pursue my research. That was really supportive. So it is really important, to be a Roman when you're in Rome. That's the key. So you need to. It's a two-way communication. So, you need to respond, and you need to, have an open mind to understand things, and, to respect each other's culture. That is very key. And also the Indian community in Ireland helped me a lot, to have that, homestay, feel of my home country. So, this is just my personal experience. But then, when we just look into traveling, to different countries, it is harder. But, following this, I have successfully, completed my PhD in 2011 in 3 years' time. And I really need to thank my, my fellow, my friends, and the total research group, who took care of me very well, and encouraged me in every point of my PhD. And this reminds, after this journey to Ireland, you won't believe I relocated to 3 different countries. I relocated to South Korea in 2011, and I was working as a postdoctoral researcher there between 2011 and 13. And I had to move to Japan in 2014. So I was in Japan from 14 till 2015. And I relocated back to UK in 2015. So all these relocations were involved with family relocation, which is a lot more challenging. We'll just discuss it in the future slides. So, but then this has made me realize that only the first time is the hardest thing. So first time when we do anything, that's the hardest. But once we do it, then it's a lot more easier, so we can just overcome these challenges. The second challenge, for women in science, I see is the stereotype threats. So women are capable and competent, but the real question is not about their ability or their capability. The question is the stereotypes in the community. So the stereotypes of their ability, societal influences, workplace, and family environments. A second. So, because I'm from India, I can just relate, the cultural differences and, the societal aspects also. So, the stereotype, thinking is like women, men leads the family, and then you need to adapt to that one. Men is the breadwinner, women needs to adjust for everything. But then nowadays, equality matters in every family. So, and then loads of discussion is needed within the family to, embrace that one. And from my personal experience, I was just working as a brain Korea postdoctoral fellow at Hanyang University. So I moved to South Korea after getting married. So, we had our first baby in South Korea. But then I got an opportunity to move to be a visiting researcher in University of Maryland in USA. So I have applied for visa. We have just made decision. That's the way for me, because I see loads of possibilities for career progression. So, we have decided on that one. But the day I got, it's irony, the day I got the visa stamped, on my passport, my husband got a JSPS fellowship, which is very prestigious fellowship offered by Japan government. So in that case, we had to think whether to take up this opportunity to go to US or to accept my husband's possibility and, to move to Japan. So we had loads of discussion within the family, and then we were just evaluating the pros and cons, both personally as well as professionally, which would be best for both of us, because none of us want to compromise our career for any reason. So, I was not ready to give up my career, and it's the same thing for my husband. So, we had healthy discussion within the family. So, but end of the day, I decided to give up my, my opportunity to go to US, and instead we moved to Japan in 2011. So, in 2013. So, but then that was later I realized that was a fantastic opportunity, or that's the best decision I would have ever made in that situation, because I got an opportunity to join Nobel nominee professor Akira Fujishima's lab in Tokyo University of Science. So that has thrown me another challenge in my career from a science perspective, because I am from from a both physics multidisciplinary background. I was working on electrochemical based biosensors, but then the group in Professor Akira Fujishima's group, they were working more on the photocatalytic materials, and they were concentrating more towards energy and environment based applications. So that was, even though I got an opportunity, then I had to think about how to take my personal scientific career forward. So I was not ready to give up my biosensor research experience. And then so I wanted to develop something. So we had discussions, and then we came up with developing photoelectrochemical based biosensors. So instead of using electrocatalyst materials, why not we incorporate photocatalytic materials and develop sensors? And one advantage with those materials are low cost materials, so that will develop light activated biosensors, at a low cost. So that was a really interesting challenge professionally for me. And we have just published a couple of papers on that, and a review article, which was received very well in the scientific arena. So it's again breaking the stereotypes and and facing the challenges, how we address that. We definitely need support from men, from family, from our society. But then we don't need to be stopped at any way because of these stereotypes. And I can also see there are loads of loads of progress even in India, to encourage women in science, and they are supporting. That is really important. So we are, facing this, and we are improving, to reduce the stereotype thinking. But there are still more, things needs to be done, and to be progressed. And the third challenge that every woman faces is the motherhood. So as an young, having kids and raising them at an early stage of anybody's career is really challenging. And I have two kids, one daughter at 8 years old and a son 2 years old. So I still feel it is a juggling act, to achieve the right balance between career, between the work and life balances. So it is hard, because especially it is hard when for people who are in STEM area, because there is no switch off time in research, because research needs constant updation of knowledge as well as the skills. So we need to constantly engage in developing and updating ourselves. So it is really the key thing. So it is very demanding to balance both personal life as well as professional life. In order to address this, some of the universities, there are maternity leaves in place, but still, I'm glad in Tamil Nadu we have 9 months fully paid maternity leave. However, in European countries and UK we have nearly 2 months fully paid maternity leave, but then we can extend. I think we can just extend it for 6 months or over 12 months period. So there are possibilities, but then it is not exactly fully paid like in India. So in that case, Tamil Nadu is in an advanced situation. However, we can just look into there are loads of the government has realized recapturing the talent, because loads of women, they drop out after having children. They are not coming back to their career. So because of all these parental responsibilities, and in the Western countries, the childcare costs are really huge. So the government is thinking about that, and they are just introducing new schemes recapturing talent. And here in most of the research councils, most of the research councils have the schemes for women who dropped out of their research over the period of 24 months. They can just come back, they can write proposals, submit them, and then they can just catch up. And then the one advantage with this one is they also allow the flexible working, part-time working. So it is not necessary we had to take 100%. So we can still work 20%, or still work 50 to 80%, something like that. But I also see there are new schemes coming up in India also, about inspire women, single child schemes, and schemes supporting women to do PhD, or they come back to research career. So which is all progressing, which is all really interesting, so which is definitely needed to to block the leakages in the pipeline, so that we get more and more women working in STEM area and achieving. So the fourth challenge is having the right mentors. So the professional mentorship is are vitally important, because when we hear from people who have been there and done that, that gives a sense of belonging, and that gives more confidence to the to the researchers, particularly at the early stages of their career. And our previous speaker rightly mentioned, professional mentorship is really important, to encourage both in the professional setting as well as from the personal perspective. And that's the main reason that I feel events like this is critical, and it is really important to share the experiences to the peers, and that will give us a sense of belonging, and that will remind the women who are all facing these challenges that they are not the only person only person facing that one, and these things can be addressed, can be improved, and then these things will pass by, and then we can still come back to our we can still follow our passion, and then come back to the track, and we can still build career. So, and also I personally feel mentorship is really critical in their professional settings also, in their work environment to regarding promotions, and getting into panels, and because promotions is another key thing, young women, especially when they are parents, their contributions, and like when they have like maternity breaks and when they are coming back to their careers, they struggle a lot to cope up with with the same kind of men who are working with them, because they don't have this type of challenges. So women face more challenges, and that acts as a limitation for them, like to progress through their career. And if you just look into the the ratio of women in higher in higher level jobs, like professors and senior researchers and stuff, like there are a lot less number when compared to men. So early career women definitely need more mentorship, to progress in their career. And then the suggestions from their peers will give them the right way of balancing their work life, the balance to get that going. So when we just look into this graph, from HESA, it says like nearly 35% of STEM students are women, only 35%. And then like when we just look into, when we categorize them between different disciplines like physical sciences, mathematical sciences, computer science, and engineering and technology. So engineering students, that are only 19% are women, and it's the same as computer science. So this is like more European, UK based studies. So, but from our Indian perspective, we can see there are more women studying STEM careers. It is increasing nowadays. But then when we just look into the women entering into the STEM career, is still limiting again, and we need to push that further and to encourage more women coming into that one. And the gender pay gap, that is also another critical thing, because even though it is all educated, but the bias still comes in different packages. And sometimes even the educated women, they don't realize that they are getting paid less than their male counterparts in the same sets of situation. So this is again institutional based issue that needs to be addressed, and policies needs to be developed, and to maintain and to assess them based on their knowledge and performance, rather than from the gender-based assessments. So the world is changing. So people are realizing that getting more women in STEM is particularly important. So I'm just highlighting mainly the cross-cutting themes across the UK and Europe. So people have started embracing positive action measures towards encouraging women in STEM subjects, female participation in STEM, and public engagement, and getting them to pursue higher education in STEM and pursue career in STEM has increased through loads of schemes. And for example, the EPSRC Open Fellowship, it's a new fellowship publicized by EPSRC Research Council, and now this allows nearly 50% of their time can be dedicated towards STEM-based activities, to improve women participation in STEM areas. So that is really, a positive change I see. And the other one is recently the Royal Society of Chemistry has announced the Freedom in Identity credit. So initially, when we just publish papers, with some name, we can't change it once it is published. So, but now the policy change will enable people to change even, update their names on the published journal. So, this is needed, when women gets married, or when they change, or when people change their gender for some reason, and then so they change their names, and they need constant updates. So these policies will make them to avoid unnecessarily undermining their identity, and then to keep their credentials going. So that's a recent change from the policy level from Royal Society of Chemistry. And the other thing is in UK and Europe, Athena Swan Award is a very famous scheme run by most of the universities. So in order to change and encourage the gender balance within the campus, and they encourage more activities, they involve more and more women into that one, and they promote women in science, women in STEM areas. So that is a very key thing. And again, another one is the Soapbox Science Festival. So it runs every year during the summertime in Europe and the UK. So it demonstrates, it demonstrates the science in streets. So, women scientists, they just go into a very, populated high streets, and then they do little experiments to attract more women and girls into science. So they show, they show the general public that what they are doing, and that acts as an inspirational for young kids who wanted to pursue science degree. So which I think is really critical from the public engagement perspective. So more and more women children, like female children, like when they see more and more women, successful women in STEM area, that will give them a sense of belonging, and then that will give them, that will boost their confidence, to pursue STEM career, and then break all these stereotypes and move forward in their career. And this is an interesting graph. Nowadays, the call for women in STEM, encouraging women in STEM, has grown a lot. And then there are different independent organizations within Europe, to promote women in science. So women in technology and science is in Ireland, and then Athena's one is mostly run by most of the EU universities. But this is what is more interesting, promoting women in science is not only not just because women need science or science needs women. It also has the socioeconomic implications. For example, if you just look into this, the graph, even with a very slow improvement in gender equality, it is suggested by 2030 we will be we will be reaching we will be improving 0.7 to 0.9% GDP per capita. So this has huge economic income for the countries, and a rapid improvement will value in billions, and then so which is really needed for all the countries. So that is why women in STEM propaganda and all the efforts that people make in women in STEM to strengthen and promote women in STEM is it is needed in every aspect for development of any country. So the future needs is from my experience, I feel things are changing on positive note. People are looking at the development in the they are valuing the knowledge and the skill set of people rather than the gender. But again, there are some things that needs to be changed. And for example, when I was spinster, I used to enjoy conferences. I used to visit loads of conferences. But after becoming a mother, it has becoming challenging for me, to participate in conferences, because that comes with childcare. And none of these conferences provides childcare support, and that can be included in most of the conferences, to encourage more women to participate. And this is the same thing, when we look into the invited speaker list, so there are more male dominated, and that's the reason. The main reason is even though there are successful women who are capable of delivering those talks, but still they come up with loads of other family commitments, which would block them from accepting those things. So subtle changes in the conference settings, but that will make a huge improvement, for and encourage the participation of women. And recently in chemistry world, Professor Eugenia Kumachiwa, she has mentioned, rightly mentioned, pointed out, the gaps between the policies. For example, there are policies to encourage women to return back to their career, but then the support so far now is given to women only after they come into career. But then to return to their career, they need at least a couple of months to develop a proposal, and that time they don't have any childcare supports. And so she has raised the right question, like, to the policymakers, whether there will be a possibility to, change that and provide any seed grant support for childcare during the proposal preparation. So when lots of women come into these things, and when they think about and when they address their challenges, then it'll be a lot more easier for the policymakers to to draft the policies, and then to bring the change. So the final thing I would like to mention is our success, or a woman's success, is not only success of a woman or just the family. It is a message to the future generation. And when we just look into the success of fellow women peer researchers, it gives a positive message to the young girls who would like to follow the paths of science, and to show them that women in science can also have an impact, and there are more possibilities for them to progress. So that is a very good message for women in science, and celebrating women and celebrating the success of women is definitely needed, and that will definitely have a very good positive note on bringing women in science and retaining them in their STEM career. So thank you all for this wonderful wonderful opportunity, and I'm still chasing my dreams. I'm going to take up a new position as a senior research fellow, senior aerosol scientist in Institute of Occupational Medicine in Edinburgh. So that again comes with a relocation to Scotland from Wales, but I'm just open for all the challenges. But I never let my any of these challenges to stop my perseverance and my passion towards research. And I wish every success to all the fellow speakers and also the participants. Never let the challenges take you. Just keep perseverance. Perseverance is what matters, and the passion is always the driving force for success of any woman, in STEM career. I wish everyone good luck. Thank you so much.
Thank you, ma'am. Thank you for such an inspiring lecture about your journey from east to west and how you are balancing your work as well as your personal life. Now we have some questions from the participants, ma'am. So the first question is from Joyce. She's asking to give some information on the grants or fellowships which are completely dedicated to the woman in UK and Europe.
Okay, yeah. So, regarding the research fellowship, so EPSRC, EPSRC fellowships are not only for women, it is for gender balance. It is open for everyone, but still there is a scheme for recapturing talent. So that is mainly particularly for women, because who stopped their research career over the past 24 months. So they should not be in research. Instead, they can be an accountant, or they can be doing some other work in their career. But if they want to come back to research, this recapturing talent from EPSRC is a key thing. And then there are other fellowships like Dorothy Perkin fellowship and L'Oreal UNESCO fellowship in EU. That is celebrating women and recognizing the achievement. So there are quite a few, and Marie Curie also, they are just it is a very good fellowship, but it is open for everyone, but women can definitely apply to that one. And in India, we have the Inspire fellowships for women to encourage them for doing PhD, and also for career for postdoctoral level work.
Thank you, ma'am. We have one more question. We have Bibi with us, and she's asking for some tips to come back to the scientific career after a break of around 10 years. So if you can throw some light.
It is always challenging whether you take 6 months career break, or 1 year career break, or 2 years career break, so or 10 years, it doesn't matter. But the key for research is to keep constant updating about the knowledge and the recent progress. So we need more time to get into that, to understand the the current trends in research, and then to come up with new proposals, to develop and then take it further. So that is key important. But then it's mainly the willpower, and it's mainly the thinking. There are opportunities, so we can just look into recapturing talent based fellowships that will let us come back to research career, particularly if we are looking at research, or if we are for studies. Again, in India, it's not happening older people coming into pursuing STEM based career after a long gap. But then in Europe and UK, it is still common. So even after 10 years break, you can come back and do a master's in nanotechnology, and you can just do a PhD in nanotechnology, and or any other STEM subject. So that is still positive. So it is just I would like to highlight here the importance of having a growth mindset rather than a fixed mindset, like our previous speaker suggested. So we can't think nothing. It is not possible. Instead of thinking about that, we can just explore new things, and having a growth mindset is the key for to overcome all these limitations.
Thank you, ma'am. Thank you for your answers. And once again, I would like to thank you for giving such an inspiring lecture.
Yeah. Thank you, Dr. Anita, once again for accepting our invitation and giving a nice talk. Thank you very much. Yeah, have a nice day.
Thank you, Dr. Nirmala, for the opportunity, and it's my pleasure. Thank you. Thank you so much.
Thank you. Thank you. Right. Bye. So we'll move on to the next session by Dr. Mitali Mukherjee. Ma'am, good evening. I think you joined. So myself, Nirmala Grace, and nice meeting you. And here is my team working with me on this program. So can I get started, ma'am?
Yeah, sure.
Yeah. So may I request Dr. Swati to introduce the speaker.
It's an honor to introduce the next speaker of our session. Thank you. So it's an honor to introduce the next speaker of our session, Dr. Mitali Mukherjee. Dr. Mitali Mukherjee is a chief scientist at CSIR Institute of Genomics and Integrative Biology, with notable achievement in the field of human genomics and personalized medicine. Dr. Mitali is also a major contributor in the first genetic landscape of Indian population, and has been an author in many publications that use IGV databases to study population genomics. Her research interest includes application of IGV data in mapping mutations, disease origin in SCAs, and environmental adaptations, discovery of markers for predicting high altitude adaptation, hypoxia responses, and outcomes through genomics. And she is also a recipient of CSIR Young Scientist Award, nominated to be a member of Human Genome Organization in the year 2006, and National Young Woman Bioscientist Awards in 2008, as well as prestigious Shanti Swarup Bhatnagar Award in 2010. And she is also elected Fellow of Indian Academy of Science in 2014, as well as a recipient of Pushpatla Ranade National Woman Award in 2017. With this few words of introduction, I welcome you, ma'am. Session is now over to you, ma'am. Thank you.
Thank you so much for giving me an opportunity to interact with your students, and I would really like them to ask questions at the end of the talk if they are interested, and if they could go through this. Shall I share my slides?
Yes. Yes, ma'am.
It's visible, right? And I'm audible, right?
Yes,
Okay.
yes.
So basically, I'll just try to take you through an area of research and try to show that how it's important to think in interdisciplinary kind of a framework in today's day to solve challenging problems. And one of such challenging initiatives which I have been associated for the last 2 decades in the area of precision medicine is what I would kind of try to take you through. Okay. So to begin with, we will put it in the context of today's time. So today, as we know that we are faced with this major pandemic, because of which we are now this time having all the meetings online, and we are not able to see face to face, which is not meaning I had also to get used to such a kind of an interaction where I don't see the face of the people. But nevertheless, it has also brought to us a large number of experiences, and also in a shorter space of time, we needed to innovate and do a lot of things which we otherwise would have taken a longer timelines to kind of develop. And anything where you want to do things in fast things fast, and also in a thing which is as important as what affects our health, we need to be also be very rigorous, and we also need to be able to innovate, so that with existing kind of a framework can we actually address the problem. So COVID is a very good example in today's time, because we all over the country, all over the world, we have gone through the same kind of scenario, and lots of things have come forth that we can actually see that as now it is nearly 1 year down the entire pandemic, the many things have got highlighted. Most importantly, there seems to be very different outcomes from the same virus, which is traveled from China, in different populations, in different age groups, in different gender. Many things are being ascribed to these differences. That could it be the role of the climate? Could it be because of the genetic differences in population? And also, even within a family, if many people are impacted, not everybody is impacted to the same extent. So clearly, there is a role of the host playing a major role in conjunction with the viral infection, so that you are having different outcomes. The second thing is that now that everybody knows that there is also a long sequelae, and sometimes some people have to be hospitalized. Some people, for them, it is fatal. So the idea is that could you get to know beforehand who are likely to have what kind of an outcome, so that could you be able to customize the treatment regime, as a result of which people are most effectively treated. So if in a family somebody is actually going through a low oxygen condition, whereas there are other people who are not going, you would want to know that, because who might require hospitalization is also important to know, right? So this is in the context of when you are getting it, how are you going to respond? But the thing is, how do you treat? If a disease is very new and not many people, meaning we do not know how is the sequelae, what are the kind of drugs which are going to be useful, and you cannot actually discover a new drug. So what has this opened up is an enormous possibility of innovations, where you repurpose the medicine based on the indication, and try to give a different meaning, try to actually use an already existing drug which has got all the clearances from the drug trial authorities, so that you are able to repurpose it. So during this time also, because everybody is looking for solution, people have also resorted to a lot of kind of traditional knowledge. Some people have availed other systems of medicine like Ayurveda, homeopathy, which, based on your value or your belief system, right? So now, and also because one of the things which has also come up is that if your immune system is weak, then maybe people are vulnerable. So how you could boost immune system, and could you actually have certain kinds of medicine which are already recommended as grandmother's recipe, or in traditional household, could you actually use it? So all these questions have come up, and in the space of this is one of the aspects which I am going to deal with, is that such a kind of a scenario which we are facing now. People who come from the traditional medicine system, for example, if you approach an Ayurveda doctor, they kind of treat you with a medicine which is 5,000 years old, and for them the reports or the X-ray, all of it is new. So as is COVID, so would also be SARS, so would also be MERS. For them, everything is new because those kinds of descriptions are not readily available, but still they treat, right? And the fact that it has been in existence for 5,000 years, there's a possibility that there is some basic fundamental principle behind it, and we need to first understand it in today's language to be able to get to see whether even in these times of pandemic, whether it can become useful. So in this kind of a framework is what I'm going to talk about today, the subject of our work, which is called as algenomics. So I'll go for from some basics just to get all of you in one page. The first is I am a genomic scientist. I have learned Ayurveda after PhD and not learned, imbibed it, because I work very closely with a doctor, Dr. Bhavna Kashyap, who is an MD in Ayurveda, and she is a colleague of mine in this institute. And between us, we've developed this area together. So I come from the genomics background. And why do I need to get into this? So I would try to pose the problem, pose the gap, which we might be able to benefit if we are able to integrate the sciences of traditional medicine, in this case of Ayurveda. But how do you go about it, right? So that's the scientific framework which we will be discussing. So since I come from the genomic space, so all of you know that all the animals, be it bacteria, be it plant, be it humans, chimpanzee, the basic makeup is driven by these four chemical letter sequences, which are the nucleotides, right? And each of these, if it's bacteria, of course, you don't have chromosomes, but the genetic material resides in the chromosomes, and this is what actually governs what kind of stories will come out of each of everybody's genome. So the same nucleotide, when it is woven in a particular manner, it might become a plant, it might become a chimpanzee, but all of it is written in what we could call as a book of life, right? So just to get the analogies clear, supposing you have English alphabet, so some similar to that, we have chemical alphabets, which are called as nucleic acids. If they are threaded together, just like the words, then they make DNA, which then go on to make genes, which with punctuation. And each of these set of genes could be threaded in a chromosome, which could be like analogous to the a chapter. And then when you thread all these chromosomes, meaning put all these chromosomes together, compile them, then that becomes the book or the genome. Okay. So all humans have this kind of nucleic acid in 3 into 10 power 9 base pairs. We inherit one copy from each of our parents, and the whole one such set is called the genome. And understanding this entire genome, connecting it to various kinds of readouts, to phenotypes, and all what becomes the science of genomics. Okay. So if we now look at the genome itself is not a message. We have the same genome in all our different organs, but we have eyes, we have nose, we have ears. So clearly, the same genetic material is not expressed in all the tissues in a similar way. So in certain parts of the cell or in certain tissues, some amount of the DNA is read, and that would give that individuality to that organ. So how is the DNA read? So the DNA is double stranded. You would have all read about it. So that is transcribed by this machinery, transcriptional machinery, to a messenger RNA, which is the mRNA, which can go out into the cytoplasm. And these three chemical letters of the mRNA are read at a time, and they encode a codon. And corresponding to that codon is an amino acid, which gets incorporated by this translational machinery. So reading this mRNA, one can thread the codon, the amino acid, and that is what becomes a protein, right? So you have DNA that would make an RNA, and that would make a protein. So now, when the DNA is replicating, sometimes it can make an error, or there could be a change. And if that change is there, then it could change the message. And if that message changes, then there could be a different amino acid integrated. Sometimes that amino acid might not do any harm to the protein, but in some cases it could also lead to certain diseases, right? So the good thing about genomics is that with everything, can people become, meaning can everybody go on to mute? Yeah, thank you. So since the entire living, meaning all the living organisms, some have the same letter.
Ma'am, sorry to interrupt you. We are unable to see your slides, ma'am.
Why is that?
Can you reshare, ma'am? Just stop sharing and again, just if you can just share it once more.
It's not there right from the beginning, is it?
No, ma'am. Beginning the slides were coming, but then I think it got stuck on one slide.
Oh, okay. I did not know that. Okay, just let me. So I've stopped sharing, and then I'll start.
And again share.
Is it visible?
Yeah, yeah.
Okay.
We can see, ma'am. Now you can continue.
Okay. So the last slide, so I can continue from here, right?
Yeah. Sure. You can continue.
Okay. So what is interesting is that since every organism has the same DNA, you can pretty much use the same technology to understand the DNA, RNA, protein of all animals, and that is what is good, interesting thing about genomes. Not only that is good, you can also compare between genomes, between closely related species, between model organisms and humans, and try to see based on conservation, you could elucidate functions. So lots of things can be done because of this sharing of common language, right, across all living beings. So the idea was that if there is a book of life, it is that not all of us are similar. That means the book of life has changes, and if one were to study those differences, then it was thought that we might be able to understand why some people are diseased, some people are not diseased, why some populations are different. So everything might be written in the genome. So there was this big project which went on for 20 years. It was called as the Human Genome Project. And the idea was that could be sequenced, or could we develop technologies to sequence not only human genomes, but also all the many genomes across the planet, and try to understand the basis of life. So the first project was meaning there were many prokaryotes and eukaryotes and viruses sequenced on the way, but the major project was the Human Genome Project, which was like 3.3 billion bases, nearly 25,000 genes. The coding part, of course, there's a huge non-coding part, but this was what was the Human Genome Project intended to do. But what has happened, and the first draft of the human genome we got in the early 2000s, but what came out very humbling experience was that even between related people, there were too many differences. And not only that, now that when people have got the technology advancements and lots of sequencing can be done in a very cost-effective way in a very short time, so people have started looking at genomes across the world, and we find that there's a huge amount of variability in the genome. So even if we look at single nucleotide polymorphism, that is the changes at one place, there are nearly 88 million variants, and then you look at structural variations, for example, recombination, gene duplication, there's a huge amount of variability. So now it becomes a challenge to understand what is the reference, and when you are comparing, when you are you comparing really the places where there is the changes because of the disease, or just that it's coming from a different population? So how do you actually define a reference genome? Next came another humbling experience that people found that not only we have human cells, but we have 10 times more bacterial cells in our body, and they colonize different parts of the body. And between people, the same part of the body has similar kinds of bacteria, but there is an immense diversity in microbes around our body, and they would contribute to even more, 10 times more number of genes. So if humans contribute to 24,000 genes, then there are approximately 220,000 genes contributed by the bacteria which colonize us, and they colonize us right after a month when we are born. So there is this microbiome, and plus people have moved to places, they have adapted to different conditions, they have admixed with different populations, they have taken to different cultural practices, for example, dairy farming. So there were dietary shifts. So as a result of which the genome has become very, very admixed. And now the challenge is, how do you from the genome sequence get to understand differences? In fact, the main, after 10 years, there was a major debate that how do you define a normal human? So if you actually ask anybody, are you healthy? Then you will say, I'm healthy because I don't have diabetes. I'm healthy because I don't have asthma. But from your health state, are you in different states of health? We do not have an answer. And unless we know who is healthy, we might not be able to understand which genomes to study to be healthy, right? Or are we differently healthy? So this is a question which has started plaguing everybody. And this is very important, because if we want to move towards early intervention, then each of us need to know how healthy we are and what is our state of health and what is the appropriate way then we should be dealing with health. So this is what has been the aim of this medicine, which is called as the precision medicine. The idea is that if you have a genome of a person, and if you are able to capture many, many different attributes of that person, for example, all the RNA that person expresses in different times, all the proteins, all the metabolites, and then could you, and then there are lots of devices, for example, people wear Fitbits or other kinds of patterns you can capture. There is a big data cloud around each of us. And if somebody is able to analyze this in spatiotemporal dimension, then you can create a map of a person which is like a GIS. It's like it's just like when you use the Google map to arrive somewhere and you want to ask it to guide you, then sometimes it will say this is a red zone, this is a blue zone, so you should take this route and not that route. So the idea is that from the genome sequence and from the expression pattern, would we be able to fix a person in a spatio-temporal context, as a result of which beforehand could we know that such and such person is going to respond to certain kinds of trigger in this kind of a manner, and so that you are able to customize that person's diet or that person's health regime in such a manner that you can individualize and be more precise in treatment. So this is what is the world is moving towards, and this is called as a precision medicine. Now, in the around the world, the way the precision medicine is going on is that you capture huge amount of information on an individual. So it is a huge big data, and then you use big computational methods like artificial intelligence, machine learning on these data to develop predictive models. And based on the predictive models, then you try to evolve signatures of a person. So this is the way which world is moving towards. But one such method is already in practice for over 5,000 years in India. And this is very interesting because just a couple of years back, Nature Outlook came out with a history of when was precision medicine in early times, whether there was a precision medicine described early, and they actually said that in India, the concepts of Ayurvedic medicines are first laid out in sacred texts known as Vedas. The goal of the medicine is to maintain balance between body, mind, and spirit, and treatments are tailored to each person's constitution, which is called as Prakriti in Ayurveda. So this is a shloka from Ayurveda text. This is from Charak, and this SU means Sutrasthan, meaning the places where the principles are described. And here, this Sanskrit text basically is the aim of Ayurveda, where the idea is if you can maintain health in healthy and alleviate disorders in disease. Now you can see from here, already there is a personalization context brought about here because it doesn't say in a population. It talks about an individual in the context of health and in the context of disease, healthy and disease, right? So this is what Ayurveda talks about, and we will in the next couple of minutes we will try to deal with what this is all about and how do we get to understand this, because this is written in Sanskrit. Most of us are not exposed to such a kind of a language. Most of us really do not know also what Ayurveda is all about. And there are many biases which prevail because of this kind of an ignorance. So, so we've been working in this area. So this is a very recent article, came in 2016, but we started this quest around 2001 when the world was moving towards precision medicine or personalized medicine, and I got exposed to this area, and I thought that if there is something existing like this, why can't we try to explore this and explore this through the method of science? And this is what is the area. So what is Prakriti, right? What is constitution type? So in Ayurveda, individuals are described on the basis of multi-system body features. So people, they look at anatomy, that is how is your body built? Are they, what is the size? Is it broad, small? How symmetrical is the body? How is the frame of the body, whether it is broad, long, shape in terms of symmetry, in terms of physiology, different kinds of parameters are measured with respect to how your appetite is, how your digestive system is, how your skin looks like, how much do you perspire. So there are many attributes one can assess. Then there are physical activities. For example, if you walk, how do you walk? Do you walk fast? Do you walk slowly? Do you move quite a lot? Does your arm move when you talk, or etc.? And then there are psychological attributes, for example, your memory, that supposing you hear a person on the phone, you immediately know who it is, or by a smell, you actually have a memory. So there are people have olfactory memory, auditory memory, gustatory memory, or how much do you get angry, what is your speed. So in multiple ways, they can classify one person using a set of methodology, and then they actually describe individuals on the basis of these attributes into 7 broad types. So it is not that we can bin every person into just discrete 7 types. It's a spectrum. It's just like you have colors, right? You have some primary colors and then you have other colors. And at one point of time, it becomes a distinct color. So similarly, you have constitution types, and these are described as here it's written as VPK, that means Vata, Pitta, Kapha, and then combinatorial personalities like Vata, Pitta, Vata, Kapha, Pitta, or if you have this 3 combinations, which is called as Vata, Pitta. So according to Ayurveda, any individual in a population can be classified into 7 broad types, and based on these 7 broad types, once they can actually predict how this person's trajectory in life is going to be. What are the kind of diseases he would be predisposed to, or what are the kind of medicines which would be most suitable. Now, this sounds a little kind of a non-scientific, but then the thing is, are there principles laid down? Can any Ayurveda doctor, if one says he's what, then how does the other person also arrive at the same conclusion? And we come from different populations, and how do you actually say I am what when my skin color, my body size might be totally different from your body size. So there are lots of nuances in this, and based on this prakriti, then one person can they can talk about their health state, the responsiveness, the disease, and the individuality. Now, how does this happen? So, what is this vast and cup? So these vast and cup are three attributes of a system which basically define the kinetic component, the metabolic component, and the structural component in the system. If you take a biochemical pathway, there would be a building up, and there would be a breakdown, and there has to be a movement, right? All the systems have that. So Ayurveda describes uh, individuals in the context of how much proportions of these are there in the system. Accordingly, so every individual will have all the three, but they might have more of one or the other component, as a result of which they could get fixed into a phenotypic space. So supposing an individual has more of Vata, then they will call them as more of Vata type of individual. If a person has more of Pitta, then that person becomes a Pitta Prakriti. And if a person has more of Kapha, then that person becomes a Kapha Prakriti. And then there would be spectrum of people who might have combinations of Vata dosha. So they would become Vata or Vatsa or Vatsa. Now, what is interesting about this is that these these proportions of dosha in an individual get fixed right at the time of fertilization. That means if an individual is of a Vat Prakriti, then he tends to be there in the Vat Prakriti, or his dosha is always there in that axis. But now, diseases are also described as perturbation of doshas, and that is why these are called as doshas. So, supposing kinetic component of the system increases beyond a threshold, then that would lead to a disease state which is called as vikriti. So, supposing this much is the optimum threshold of Vata, but if it goes beyond this, then it would be called as Vata vikriti. If it goes beyond in this direction, it will be Pitta vikriti or Kapha vikriti. Now you can realize that if an individual has higher amount of VAT, for this individual, this amount is not a disease state. But if a person is of fixed Prakriti, whose dosha is optimally this one, then a little bit of movement in this direction, what is a homeostatic for this, actually will become a disease state for this individual. So that way, an Ayurveda doctor assesses what is the baseline of your dosha to be able to then assess what kind of perturbation has happened when there is a disease state, and what is the nature of perturbation. And accordingly, the drugs are also classified as to what dosha they work on to bring it back to homeostatic state. So this is called as a common organizing principle, and this forms the basis for assessing the cause of disease, identifying the disease state, which is called as Vikriti, and also identifying suitable kind of drug which will get your vast presence up to your homeostatic state, and not every individual to the same homeostatic state. So this is called as three dosha, the three components which form a common organizing principle, and the connectivity of them is called Sri Sutra. Sri Sutra means connection between Hetu, Ling, and Aushad. So one connects, if one can connect the cause with the phenotype or features with the disease, then this becomes something which is called Sri Sutra. In modern times, people are talking about in this context in the precision medicine as network medicine. That if you understand the causes through the phenotype, then you would be able to identify what is the most suitable or optimum drug for a person. So now vast and cuff is found abstract. What do you mean by kinetic? Can you assess what is kinetic and how do you measure it? Right. So these are also described. So these are all Sanskrit shlokas. So if I have written it over here, it might sound like a standard biochemistry textbook, but you have to believe me. But if you are able to, some of you are able to read Sanskrit, then you might be able to kind of read through. So these are the English translations of the Sanskrit text. So when they say kinetic component, what governs the kinetic component, then there are vivid descriptions about what do you mean by kinetic component? So it talks about manifestation of shape, cell division, signaling, movement, transport, excretion, initiation. So all these functioning in the body is governed by this kind of a dosha. When it comes to Pitta, then it governs metabolism, digestion, energy, pigmentation, all these aspects. And Kapha is something which gives structure, shape to the body, gives growth, lubrication, etc. So the functioning of the cuff is in this space. So these are the functional attributes. Now, this is basically what do they do. But then how does that translate into a person becoming vast or a person becoming fit? So what is very interesting is that uh, just like I had mentioned that you have the same genetic makeup, but all your tissues do not express the same kind of genes, right? There are epithelial cells, there are bone cells, there are brain neural cells. So everyone would express differently the DNA. It will open up differently, so you make different kinds of RNA. So according to Ayurveda, where three dosha is a common organizing principle, if DNA is a common organizing principle for genomics, then in Ayurveda, three dosha is a common organizing principle. Then they have also descriptions about which of the cell signs are more enriched in what kind of doshas. Okay, so according to Ayurveda, there are, based on these descriptions, there are seeds of Vata enrichment, there are seeds of Pitta enrichment, and there are seeds of Kapha enrichment. That means individuals will be of a particular dosha, but their tissues are also have enrichment of particular doshas more in them because those kinds of functioning is needed more in there, right? So according to Ayurveda, these tissues are enriched in Vata, these tissues are enriched in Pitta, and these tissues are enriched in Kapha. So now you can understand if a person is of a Vata Prakriti, that means he has elevated amount of Vata. Okay, so if he has elevated amount of Vata, then these tissues will actually manifest more of that functioning because they are of Vata Prakriti. So this will be evident in movement, in walking, in memory, in bowel and bladder movement, in body frame, in auditory memory. If there is a fit, then these are the places where there would be more evidence of the person's phenotype. And if the person is cuff, then these are the places then there, or these are the ways by which you could actually assess the differences attributed by cuff. So that means an individual in the homeostatic state can have this, but if there is a disease state, then there are certain tissues which are more vulnerable, and there are certain people who might be more vulnerable in these organ systems because they have more of Vata. So this is the common threading of the dosha to the phenotype. So what is described is that how does this manifest? So it is described that parents would have particular dosha, and during the intrauterine environment, the mother will also have a particular diet lifestyle because of which it could also govern the dosha, it could modulate the dosha, and as a result of which when a person is born, it would be a sum total of the genetic and the other components and also the intrauterine environment because of which the person will have a particular phenotype and that phenotype will allow them to predict the trajectory. Now this is given by very vivid Sanskrit shloka. For example, Shukra Shonit Sanyoge means the concept of genetics, Kal Garbhashay, that means the state of the or the season of conception, and Masur Ahar Vihar, the way the mother eats or the diet of the mother. And then there are these terms also given Jati Prasakta, Kul Prasakta, Deshanupatini, Kalanupatini, Vayanupatini. That means if you look at an individual or individual variation, it has to be contextualized by what ethnic background they come from, if things run in the family, if they reside in a particular geography, if there is a particular time you are assessing or in age you are assessing, then you have to assign all these things before you assess a person's prakriti. These in the modern terms will actually be different subjects: population genomics, heritability, geographical genomics, aging. All of these are different subjects have been dealt in one sutra in the charak, right? So this is a conceptual framework, and we are trying to get it to a modern context, because these all terminologies which were known to Charak or Sushruta many years back is actually also is the language which people are talking about now. What is more interesting is the temporality of these Prakriti types. So, for example, people are born with a particular Prakriti, but clearly you would see that when you age, you grow in size, you have predisposition at a particular age. Some people have problem at a particular time of the year, you have particular problems. So there are health states, there are slight deviations from the health state which are allowable, and then there are disease states, right? So why does that happen? So according to Ayurveda, there are dosha governing things also attributed to age, to climate, to season. So, for example, when people are born to the time they are 30 years, there is a lot of growth in the system. So, everybody will have more cough in the system. But what happens is, if an individual is of a cough prakriti, then they would have more abundance of cough, whereas the other individuals will not have more of that cough if they start with different prakriti types, right? But if they are fit is there, fit is more in the middle age, Vata is there in the later age. As a result of which, Vata individuals might have more predispositions for Vata in the older age. Kapha individuals might be more having problems in the younger age, and Pitta might be in the middle age. So also at different seasons, it is described that cough increases in everybody. So people who are of cough prakriti might have more problems in spring season. People who are of vata prakriti might have more problem in monsoon season. People who are of pitta prakriti might have more problems in the autumn season. The prakriti, the dosha also fluctuate during daytime. So 6 to 10 in the morning, they say is cough time. 10 to 2 is pitta time, and 2 to 6 is vata time in the morning and evening. So Ayurveda doctors also, when you go with a particular disease, they will ask you what time of the day, and accordingly they will know what kind of dosha might have got perturbed, because there is a particular time of the day, right? So this is the temporal. So what I was talking about, the GIS component, the exposome component, that is also defined in the context of a prakriti of a person. And also there are various diseases which are described. So Vata individuals are described to have 80 diseases, which are some of the English translations are given over here. Pitta individuals have more of bleeding related disorder or inflammation related disorder. Kapha individuals are more having diseases which are linked to obesity, atherosclerotic conditions, etc. So this is a knowledge, and now you can understand that there is a subject matter, meaning there is already a subject matter existing, but it is written in a very different context, in a different way. And if I'm wanting to integrate it the modern sciences, because the principles are what precision medicine is moving towards, how do I integrate these two sciences, right? So this is where I will draw an analogy, that if I give you these words, right? Since this is a key, I will maybe give you all the answers, but I mostly give it as a quiz. That if I give you these words, and if I tell you that all of them are similar by a common thread, many of you might say it is A, right? Many of you might say it is some kind of a color, but then all of it does not seem like a color. Okay, but if you go to Wikipedia and you write this and color, you will actually get a color. That is absolute zero. This is the color. Acid, this is the color. But if I ask you to say, if I say acid and draw the color, you might not be able to draw the same color, right? It would also show up differently in different media, right? If you want to arrive at the same color, what you need is an RGB code. You need to define a particular color, and if you define that number, then you can use this color to make any shape, right? So when I'm talking about Ayurgenomics, when I'm talking about integrating Ayurveda with the modern science, I need an interface, so that what this is being talked about, what this shape is, I'm able to get the whole connect into a common language, right? So this is what was the thought process, that if we want to contextualize, or we want to make Ayurveda modern, then we need to first understand it in the context of a modern sciences. So we had to have a working hypothesis. Idea was that if people are at the end of the spectrum more predisposed to certain kinds of disease, if I take the blood samples of these and if I study them at the genetic level, would I get genes related to metabolism overexpressed in them? Would I get genes expressed with respect to transport and signaling more in vast people, as is described in Ayurveda? Would I get genes related to storage function more evident in tough individuals? Or since they are differently predisposed, would there be more predisposition of a particular kind of disorders in these people? So this was our working hypothesis. How do we go about it? So what we said was we will take a set of people who come from a genetically homogeneous background. I'll not get into how do we establish homogeneity. That is another project called the Indian Genome Variation Project. You have to take my word for it that we need to study them in a people who are otherwise homogeneous, come from the same ethnic background, have the same basic genetic makeup. And then classify people who are at the end of the spectra, VAS, PIT, and CUF, take their blood samples and measure different attributes of expression, for example, expression, biochemistry, and then try to see whether there are differences and synthesize them with the modern terminologies and try to see whether you get differences. So this is what we embarked on very long back, around 2002, and we took people from a particular genetic background. The color indicates that these people are all from the same genetic background, classified them using a questionnaire, which took us a long time. Bhavna has developed this questionnaire to identify people who are at the end of the spectrum. We said that let us first look at the ends and then work about the other people and then try to see whether there are differences. Now I'm cutting a whole story short. One thing which we got was biochemistry parameters. If you go to any path lab and you do your blood test, then you find a range. It is described that if you are within this range, you are healthy. But what we found was that even within the normal range, vastus and cup tended to have their own ranges. That means for PIT, this is the homeostatic range, and if they move from here to here, they might become disease. But most of us would, all of us would actually define when all these people reach to this stage. But then for them, for PITs to reach this stage, is they might actually be in a pre-disease state to move from here, and for VAS, they might reach this stage faster, right? So we found that many biochemical parameters, for example, lipid profiles, hemoglobin, what we talk about broader ranges, if you classify people on the basis of prakriti, healthy individuals, you find that they have defined spaces within them. Then when we look at gene expression patterns, we actually find lots of processes to be different in them by from their array. We use an array which can measure all the genes at a time from the peripheral blood and try to ask whether there is overexpression or underexpression of particular kinds of genes. So for example, we got overexpression of genes linked to cell cycle, more in Vata Prakriti compared to Pitta and Kapha, and then there are genes related to immune response, more in Pitta compared to Vata and Kapha. So like this, we got a lot of information. Then we went back to literature and we actually find that there is a shloka in Ayurveda where they talk about Parmanu Bhed Na Parisankhya. Something like that is a work of Vayu or Vata. So this is an iterative genomics approach where if we are trying to get the subtitles meaningful, that if I am telling something in my modern language, is there a connect to Ayurveda? And then can I take this information further and iteratively build on this, right? So this was our first paper where we gave the first evidence that if you classify people on the basis of constitution type, then you might be able to get differences at the molecular signature. Now the question is, if you get these differences, are these differences meaningful? How do Ayurveda doctors looking at Prakriti tell that they're predisposed to certain kinds of diseases? Do these such kind of signatures, do they become evident at the molecular level if we classify people by Prakriti? So again, I'm cutting a whole story short. We looked at genes which differ in expression. We looked at the genetic makeup or the genes variation in those genes. So typically, we would either sequence them or look at particular region variations, okay, and try to see whether they differ between Prakriti types. So one such gene we discovered, there were many genes we discovered, but one such gene was very interesting. This was a gene which is an oxygen sensor gene. So, you know, if you go to low oxygen condition, your body has to physiologically adapt to that low oxygen condition. So you will have to do angiogenesis lots of processes get changed. You will have to stop some functions. Your biochemical pathway shifts to glycolytic pathway. So many calibrations have to happen if you are in a low oxygen condition and if you have to cope up with low oxygen conditions. Now, there are genes which will detect this low oxygen condition and would calibrate. It turns out that people also differ with respect to this gene, which allows you to cope up with low oxygen conditions, such that some people can detect low oxygen at low threshold and some people might see higher threshold. So as a result of which, their coping mechanisms might differ, right? So we found that there was this gene called EGLN1, whose one state was linked to higher adaptation to hypoxia, and the other state, so if this was expressed high, then it was linked to low adaptation to hypoxia. We found that tough individuals were more like having low EGLN1 expression, and fit individuals had more less EGLN1 expression. And so it was like you could predict, could they be better adapted at high altitude? So what did we do? So we had a genetic marker which was linked to this expression, and we looked at that marker across the population of India. And what we found was that populations of high altitude had the marker which was same to the fifth classicity. So that gave us a lead that maybe sea level people, if they have certain kinds of genes which give them, which are similar to the ones who are already adapted to high altitude, would it be possible that these people, if they go to high altitude, they would have more kind of a problem? So we could not have these individuals, but we had the genetic variation linked to such a state. And we had people who went to high altitude and suffer from a disease called high altitude pulmonary edema. So we looked into their genetic makeup and we actually found that they were more enriched in variations which were linked to cough prakriti, whereas people who did not have that problem were more like the fifth prakriti. So that, what does that tell? That much before, even if you go to high altitude, if you are able to classify people on the basis of prakriti, maybe you might be able to tell who are the people who are likely to do better in high altitude and who might be also need to have certain kinds of checks in place so that they are able to cope up with high altitude conditions. So this was the first kind of a paper where healthy individuals who had not been exposed to high altitude allowed us to discover a gene which could be relevant in when you go to high altitude. Now, then, like I said, for everything we go back to Sanskrit and shlokas, and we find that Ayurveda also describes high altitude, Kshitidhar, meaning very high altitude, where there is kapha vata predominance. And the idea is that if that provokes kapha vata, then people who are of pitta type would be more better habituated. So there are all these descriptions, and this was the first time when we could show that even by using a method of stratifying people on the basis of a very ancient system of medicine, we are able to make very modern discoveries which could actually be very relevant. And this gene has now been replicated in multiple altitudes of the world, Kyrgyzstan, Croatia, and all, which actually makes us think that this is really superbly interesting discovery which got us out from got us through from this approach. So then putting it in perspective, we could see people who are classified by features could be differently adapted to high altitude. So then our colleagues, what they did was they said that if we actually then alter hypoxia, will that be consequential? And they found that if you alter hypoxia, then asthma could be modulated. So from this lead of a gene, one could actually modulate this high oxygen sensor and show in a mouse model that if you modulate this gene, then you are able to modulate asthma, which tells that if you have inherently differences with respect to EGLN1 expression, even who will be differently predisposed to asthma might be governed, right? So now when we have this experiment, then we said that if we get a model in which pith cough perturbation leads to asthma, if we take a drug which is used to treat pith cough perturbation in Ayurveda in asthma, could we actually see whether it actually intersects with hypoxia? And this is what Bhavna, my colleague, has done. And she has taken a drug called Adatoda Vasika. and used it in this model system, and by a very series of interesting experiments has been able to show that this drug actually alleviates hypoxia, changes the shape of mitochondria, and as a result of which could also work in severe asthmatic conditions. Okay, so this is how we connect the sciences from the feature to finding out whether it could be druggable, and then finding an Ayurveda medicine, putting it through the same model to see whether it actually works. So then this is a robust mechanism. So from this part of the work, I would summarize that from a 3,500-year-old knowledge, we can stratify people on the basis of Ayurveda, identify molecular axis, work it out by looking at populations, model systems, and find out whether it is replicated in other cohorts, and like that we actually close the loop, right? So this is one way of looking at it, right? Now, then is it oxygen sensing is the only thing? Then we looked at other things, and we could find that there are other immune response things. For example, there is this innate immune response, which is which has come to the fore in during COVID time. There is this SARS-CoV-2. It has a double-stranded RNA virus, and what it does is it actually activates the innate immune system, and all these pathways get activated, as a result of which it's a host way of coping up, but too much of this also leads to sometimes drastic consequences of cytokine storm and things like that. When we look at Prakriti, we find that at the genetic level, many of these genes which are used in innate immune response differ with respect to different Prakriti types, not only at the genetic level, but also at the expression level. And if we actually see which Prakriti types, all these which have been marked by blue fit seems to differentiate with respect to these genes with at the Prakriti level. What does this tell? This tells that there is a possibility that if you stratify people on the basis of Prakriti types, maybe different Prakriti types might be able to fight the virus differently. So it might also get relevant to stratify people to see whether variability in outcome in the COVID time could actually have been because of differences in their inherent Prakriti types, right? So to be able to take this study further, we have been analyzing patient samples who have got COVID, and we also use publicly available data, and we in fact find that genes relevant to hypoxia, genes relevant to interferon response, that was the pathway, actually differ meaning rises in people who are suffering from COVID, and that actually gives us a signature that if these are the ones which are implicated in the disease, then variability in them would also govern differences in their susceptibility to disease. So we've been doing this analysis, and you can see all the innate immune response papers have come up recently, and people are saying that there is a higher innate immune response in people who are differently susceptible to COVID, and that makes this study very contemporary. That in today's time we classify people on the basis of Prakriti, maybe we might be able to see why people got different outcomes, because that answer still is not there available for us. So this is one such framework, that how if you have hypoxia and hypoxia axis, then how this could be actually governing differences in outcome, and how this could be also very relevant in such kind of a contemporary situation. This is relevant in many disease conditions, but just to contextualize it to today's times, because we are all going through the same kind of a pandemic across the country, this becomes very, very relevant. The next 5-10 minutes I will just take to, can I go ahead and just show another aspect?
Sure, ma'am. Sure, please carry on.
So this, the next aspect is that one thing is that why people respond. The other is how do you actually, if somebody tells you take this Ayurveda medicine, how sure you are that you should be taking it, right? Is there a way by which you can create this evidence faster? And so that a lot of Ayush recommendations have come during the pandemic time, and people are always confused because they try to understand: can I have modern medicine? Can I have Ayurveda medicine? If I have both of them, will there be problems? How does this work? And there are more questions we ask from Ayurveda medicine than not from modern medicine, though we as patients do not understand either one of the sciences, right? But we are biased about it, right? So we wanted to also develop a platform which will allow us to query this. How does this work? Right. So the query could be same through the same Trisutra framework because all these are interlinked. So now can I use a drug and can I use it in a system so that I used to see with the drug, can I actually get some molecular signature? And will those molecular signatures then lead me to a disease or a disease condition or a therapeutic condition, as a result of which what Ayurveda drug is used for what purpose, can I actually assess the meaning of that. So we took, because this is the way Ayurveda does repurposing, that today if a patient of SARS-CoV-2 would go to an Ayurveda doctor, they would look at the features, and based on the features, they will say this is the Vikriti, and based on that Vikriti, then they will give a appropriate medicine. Now, if that principle is followed by them, could we query them in a molecular framework? So, is repurposing possible by an Ayurveda drug? And so the question was, can I then use a whole plant extract and query it? So this people are using artificin. You've heard Chinese traditional medicine. A person got a Nobel Prize because of a traditional way of using artificin for malaria, right? So similarly, we took an example drug. This drug is called as Chrysanthus pereira. This drug is very interesting because it is used in different parts of the world for many different kinds of diseases. In Ayurveda, it is used to treat hormonal diseases and fever. Now, this is very interesting. An Ayurveda doctor uses sometimes one medicine for many conditions. And you will not in modern times think you going to gynecologist, they will solve your fever, right? But an Ayurveda doctor treats that. And sometimes we think that that's a weakness of the system. How can, if we are specialists in modern medicine, then how can one Ayurveda doctor treat so many diseases, right? So, but we ask the question that if such a contrasting disease is treated by one medicine, can we see whether they are linked by a particular molecular pathway, and because of which then can we interchange the drugs from one to the other? Is that the way Ayurveda people do it? So is there a link between estrogen and viral inhibition? Because that's what they both of them, this drug is used for. So we actually use the platform. This is called as a connectivity platform. We will not get into the details. Only thing is what it allows us to do is that there is a database which has been generated on millions of compounds which are used as drug signatures. What is done is any new drug which you want to know what pathway it is, you actually treat a cell line with that drug and put it through an array or an expression array where you measure expression signature. And such kind of an expression signature has been made for many different drugs. So you do a pattern matching. You match the signature with already existing compounds. And if your pattern matches some existing compound, and if you know the function of these existing compounds, you can use this for that one in which the pattern has matched. So now what you can do is you can take an Ayurveda combination and you can put it through this kind of a platform after treatment and try to see what it matches with. And once you are able to see that, then you will be able to get a class of drugs or a class of genes which share the same pathway, and then you can arrive at a particular pathway. So we used this. We took Chrysanthus pereira, took it through the same pathway framework, and then looked at what kind of connectivity it gives. But we also had a additional information with us that it also has something to do with hormones, where when we just do a genomic experiment, maybe you will not be able to spot the hormone, but we went with the knowledge base of hormone and fever. So we did this kind of an experiment and we tried to see what do we get. So the first thing we got was that this drug at different combinations targets estrogen related pathways. So because by this pattern, we can match what kind of genes it does and whether those genes are implicated in particular kind of condition. The first link we got was the estrogen link, which told us, okay, this medicine, if it is used in hormonal disorder at the molecular level also, it shows an estrogenic signature. And the estrogenic signature is because of modulation of an estrogen receptor whose levels go down in the presence of this drug. Okay. Now, then we ask, if this drug works through the estrogen receptor, there are methods of docking them, protein docking. So if the crystal structure is known of estrogen receptor and the molecules are known in this drug, we can dock them and we can try to see whether it actually binds to important locations, because estrogen receptor is also a very important prominent target in cancer, and it binds beta estradiol or tamoxifen. We find that in the same pocket, number of molecules in this drug actually bind. So this told us that there is a potential of this drug to bind an estrogen pocket. Next, when we look at the kind of medicines with which it gives connectivity, we find that there are lots of protein synthesis inhibitors with which it gives a very high connectivity score. And most of these protein synthesis inhibitors are used in dengue. So then we had a system in place where there was a dengue infection to a cell line, and we gave the drug, and we could actually find that if compared to control, the titer came down when we used this dengue medicine, meaning this medicine in a cell line which was estrogen responsive. Okay, so this is the dengue titer which came down when you actually give the drug, and when you knock down estrogen, then you find that to some extent this alleviation of dengue signature is gone. So this told us that this drug could be used for inhibiting dengue and it could be working through the estrogen receptor. But then what happened during this time? COVID also came, and there were a lot of reports that estrogen is also one of the major signatures which come in COVID. So we took the patient's transcriptome and we compared it with what happens when you treat it with drugs, and we actually found that a lot of things which go up in COVID, this drug is able to get it down at the informatics level. So what we did was we actually had a cell culture facility where COVID infection is done in CCMB. So we gave them this drug and we asked them to check in vitro whether this drug is able to bring down the titer of SARS-CoV-2. And when we gave the full alcoholic extract, we actually could get viral inhibition to 98%. And if we gave single molecule compounds which we could isolate from this drug, we actually found that there were varying degree of inhibition by even the compounds, which actually the docking study had shown that some of these compounds bind to the same receptor. So now you can see from a knowledge of Ayurveda through a genomic framework, we actually could get a molecular link to their basis of treatment. And that molecular link, because it was shared in COVID-19, we also have a reason to believe that this drug is likely to work in COVID. And if the Ayurveda doctors are recommending this during COVID, maybe availing this medicine might be useful. So I would like to end here that how we can actually use Ayurgenomics framework to address very contemporary problem of being able to stratify people through this dosha perspective, or also able to understand the basis of how these multi-component formulations can work and maybe use it for treatment of novel diseases. So Ayurgenomics seems to be the new because it already has an advanced system for health management, and it can propel lots of discoveries, and that's what we are very excited about. We have a center where we are doing more such discoveries from different geographical regions. We are stratifying people, studying them at all levels, and trying to see whether we will be able to implement them in health settings. So I would like to finish here, and I would like to give acknowledgement to a very, very multidisciplinary team. Dr. Bhavna Prashar, she's been key to this. She is a MD in Ayurveda, and we've developed this area together. And all the ones which are in one color, they come from one background. So there have been Ayurveda doctors, there have been informatics people. So in the bracket, they are doing their PhD, some who are doctors who have done their PhD or they came for postdoc. So there have been genomics people, modern medicine people, pharma people, physiology people. They have all contributed to these studies, and we've had collaborators from various kinds of backgrounds, from medicine, from high altitude physiology, from informatics, from statistics, from metagenomics, and these are the people with whom we collaborated for infection, stem cell biology, plant chemistry for the Suzanne plus Pereira and the dengue model and docking study. So if one wants to innovate, then we require an interdisciplinary team. He has been our mentor, Professor Brahmachari, with whom I initially set up genomics in our institute, and he's been our guiding person. And there have been some very fantastic collaborators from a cohort, and we've been supported by DSP, CSR, and Ayush, and a lot of other collaborators across the country from different fraternities with whom we are doing this. So I'll end now and stop sharing. Thank you.
Thank you, ma'am. Thank you for such a detailed and inspiring lecture on various aerogenomics for precise medicine. And now I would like to mention some of the questions which have been posted by the participants. And one of our participant, Akshay, is asking about is there a way in which we can change our prakriti, and if yes, then which would be the best way of doing it? Can it be done via the food intake or etc.?
Okay. So Prakriti is something which is your baseline state. So you cannot change your Prakriti. But because of Prakriti, you can sort of estimate that what are the most likely predisposed state you will get into. For example, if you are of a Kapha Prakriti, then mostly you will have a tendency to have diseases which are of Kapha Vikriti, right? Now Ayurveda has food which are used when Kapha Vikriti happens. So you can actually practice that kind of a food habit which will keep your Kapha Vikriti in check during different seasons. If cough increases and you are of a cough prakriti, then what are the kind of things you should do to avoid that? So you could actually move out from that place, or you can have a different food which will increase pitta or vata so that your cough is reduced. So that is what is this prakriti all about. That if it tells you what is your individuality, what is your inherent constitution, and how does this inherent constitution get perturbed, then earlier on, can you actually use it to check it? So Prakriti of an individual doesn't change. Prakriti, based on the Prakriti, the patterns of changes could be Vaikaric, which is the instability in homeostatic threshold, or Vikriti, which is a disease state. So Ayurveda talks about early interventions, and they have something called Shat Kriya Kal. There are 6 stages of intervention, and if you are able to, meaning if you get a good Ayurveda doctor, earlier on, before the disease manifests itself full blown, there could be a chance to get it back to your homeostatic state so that the next stage does not happen.
Thank you, ma'am. And we have one more question from Dr. Vimala.
What is the question? It is muted. We cannot hear you. I cannot hear her. Can you people hear her?
Good evening. Can you hear me, ma'am? Yeah, it was a wonderful presentation. Thank you for your elaborate lecture. I just have one question. Do you think traditional medicine has been duly recognized in our country?
So traditional medicine due recognition is not being given in our country because of our ignorance, and it's high time. So many of us speak because we are not aware of the depth of the knowledge which is there in the literature, because it is a very different language. So frankly speaking, I don't know Sanskrit, And till my PhD, when my Dr. Brahmachari told me to go to an Ayurveda doctor and understand this Prakriti, I went to a historian. I did not know that there are Ayurveda doctors who actually study this day in and day out. So there is a lot of ignorance because our mainstream education is very disjunct from what education is there in the Ayurveda system. There are lots of documentation. So I will say that I have maybe gone to 1,000th of the whatever is written, and if we need to kind of write it off, or we want to say that this is not science, we need to also negate it by a scientific temper. Lots of drugs have been discovered from Ayurveda. Lots of pharma companies have discovered Taxol, Lizapine, all from Ayurveda medicine. They don't go to the jungle to collect the plants. They go to the Ayurveda doctors to ask what they use for treating. But when they get the active principle, then they think that that is the science. So that is not correct. One has to understand the principles, only then one can understand the whole thing. So that kind of a recognition has not come to this science, and we need to build interdisciplinary framework so that we can enable this crosstalk from happening, meaning crosstalk happening, so that there is more credibility built around this for the modern audience.
Thank you.
There's one more question, ma'am, from the participant Nalini. She's asking that how yoga and meditation can help us in attaining homeostasis.
So yoga and meditation, I'm not an expert in it, but I've heard a couple of lectures. And what people have been doing is they have been doing physiological studies and they have been doing expression studies to see what gets impacted when you do yoga and when you do meditation. And people are finding that autonomic functions like the parasympathetic sympathetic balance is attained, and there are certain signatures now people are studying, which is like, it's called CTR, a core transcriptional response to adversity events. So there are certain kinds of genes which get expressed, which are of pro-inflammatory nature. And for viral infection, you have lower expression of that, then you are more having viral infection. Now those very signatures are impacted when you do meditation. That means your inflammation goes down a little and your immune system gets better through this autonomic function. So people have been studying this at the MRI level, at the molecular level. So there are certain ways by which the balance, if it comes back, your autonomic function, then homeostasis is retained. But I am not an expert in yoga and meditation. I plan to integrate that at some level, but at this point of time, I've only delved in Ayurveda.
Thank you, ma'am.
Yeah. So thank you once again, Dr. Mitali ma'am. It was a nice presentation, and thank you once again for accepting my invitation. Thank you, ma'am.
Thank you.
Have a nice day. Yeah.
Thank you.
Thank you, ma'am. Bye.
Yeah.
So the next session will begin at 7:35 p.m. With the Nobel laureate Dr. Donna Strickland. And I request the participants to kindly join us again back at 7:35 p.m. sharp. And the feedback link will be circulated during the last session. So by that time, hope to see you soon. Thank you.